This conference will now
are
be
the
recorded.
co-chairs of the TAC, and we have a packed agenda. So we want to move right in, make sure we have enough time, one, to take in all of this amazing information, but also be able to have good conversations around that. So with that, we'll be starting with Marcus and Kara to provide a revised critical coastal habitat assessment methodology.
Turn over controls to Marcus.
All right, how's that? You see my screen?
Yes.
Excellent. So I'll try to keep this relatively brief because, as Kelly said, we do have a packed agenda. The first item we want to discuss today is basically some proposed revisions to the methods for the critical coastal habitat assessment. So I will familiarize everybody with what this project is all about, and then talk about some of these proposed changes that are open to discussion for the group. I'm also co-presenting this with Dr. Kara Radabau. I'm going to go through part of the presentation and then hand it over to Kara for the last couple of slides, and then we can have a discussion about some of these proposed changes. So goals for this talk, as I said, I want to go over what this CCHA project is all about and what we're trying to do with it, some of the methods we're proposing to change. And in particular, there are 3 items up for discussion. One of them is proposed reduction of sample effort for vegetation transects. The second is replacing methods for sampling trees with the original PCQ method with another method, and then proposed change to shifting vegetation zone markers along the transect. And so if you're not familiar with CCHA, these methods won't necessarily make sense right away, but I'll go over what these changes are, both talking about the current design and how we're proposing to change them moving forward. And overall, the idea is to reduce sampling effort in the field while not sacrificing the data we get from the surveys. So CCHA is really a very long-term project. It started about 5 years ago and will continue for the next several decades. So we want to make sure we get these methods right. But the overall goal is to evaluate the effects of sea level rise on emergent tidal wetlands in Tampa Bay. So these emergent tidal wetlands are the critical coastal habitats, particularly looking at mangrove forests, salt marshes, and salt barrens. And this does have ties to our habitat master plan, which we've talked about in the past with the TAC. We have targets and goals for these habitats, but this CCHA project gives us a really more precise look at on the ground how these habitats might be changing. And the expectation is, of course, with sea level rises that these habitats will shift landward from the coast, and so these surveys are designed to track that shift. So we're expecting habitats like mangroves to shift higher in elevation, and we might see on the other end loss of coastal uplands as a result. And so that's sort of the expectation. We're doing these surveys every couple of years and tracking these changes over the next 50 years or so. There are currently 9 sites where we're doing CCHA surveys. We've done 2 rounds of surveys so far. First one was about 2015, 2016, and the second was in about 2018. So we have 2 rounds of surveys so far. And as I said, we're going to repeat these surveys every 3 to 5 years for the next few decades. At each one of these locations, there's a bunch of data that's collected. There's vegetation transects, there's tree surveys. We're also looking at shifts in vegetation zones, so mangrove habitat, salt marshes, things like that. There's elevation surveys that are also tracked at each one of these transects, so very high resolution estimates of the elevation relative to the sea level. We're estimating, or we're looking at soils, doing soil surveys, feldspar profiles, looking at interstitial salinity, so what's the pore water salinity, seeing if that changes over time. Surveying faunal communities and taking LIDAR surveys every once in a while to get a really precise estimate of the vegetation. The current design of each one of these sites is basically a transect. So the transect runs from the shoreline all the way up to the uplands. So this is just sort of a mock-up of what that transect might look like at one of these sites. And along the transect, we're taking these quadrat samples every half a meter. So these solid black boxes show the vegetation surveys. And then these larger red boxes are the tree surveys that are also done. And so Kara will talk about proposed changes to these methods, but right now the tree surveys are done using a PCQ method, so point center quadrat. And there are some drawbacks to that method for this type of survey, but this is the general design. And so again, this is designed to basically track changes in the vegetation and tree surveys from the shoreline to the uplands along these different vegetation zones. So you see these broad zones here that we're also tracking. So mangrove fringe, transition to salt marsh, and then uplands. So I'll be talking about the first issue for the vegetation transects. As I said, these are basically collected at every half meter. So every half meter, there's a quadrat that's thrown down. And within that quadrat, what's measured is the species that are there, as well as their basal cover. So it is quite time intensive. I've never done these surveys, but I've heard from in the field that it does take quite a long time. So the question we have is that, can we actually just reduce the effort to collecting these vegetation quadrats without sacrificing the information we get from them? And that information we care about is, of course, what are the species that are there? So what's the total richness along the transect? Also, what is the total richness within each zone along the transect? So what's the richness in the mangrove fringe? What's the richness in the salt marsh, and so on? Other questions of concern are, if we reduce effort, what are the elevation estimates for key species? So what is the elevation where we see mangroves? Do we see changes in that estimate if we reduce our effort? And also we want to be able to say, are the zone delineations along the transect, can we identify that with some degree of precision if we reduce the sample effort? So I'm going to go through some slides that show changes in these estimates with reductions in effort, just to sort of make a case that we can reduce effort without necessarily sacrificing the information. So what I did was basically I took the existing surveys, so the first rounds, the 2015, 2016 surveys, and then the 2018 surveys. I'm going to call those phase 1 and phase 2. And basically took that, so again, those are sampled at every half meter for the vegetation surveys, and looked at if we can reduce the effort at half meter intervals, going from basically the true data at half meter sampling to 1 meter sampling to 1.5 meter sampling, all the way out to 10 meter sampling. Obviously, as far as 10 meter sampling, that's an unrealistic reduction in effort. That's a huge sacrifice of information, but I just wanted to see what is the trend and the metrics we get going all the way out to that sort of high end of reduction of effort. And so this is the reduction, and this is sort of the percent reduction in effort. So going from half a meter to 1 meter is a 50% reduction, and so on. So all I did was a desktop analysis. So for every survey we had for each site, this would basically be, this is a hypothetical transect here, going out from 0 meters to 30 meters. Most transects go out to 150 meters, but I'm showing you what this subsampling design looked like when I did this desktop analysis. So I took the original survey that was sampled at every half meter and basically broke it down to sampling every 1 meter, every 1.5 meters, and so on. And again, I went all the way out to sampling every 10 meters. But for every individual transect, I could take different replicates, if you will, of this subsample scheme. So for example, if I was subsampling every 1 meter, I could subsample at this mark, this mark, this mark, or subsample at this mark, this mark, this mark. And so that's what I did for each transect. And obviously, the larger you get out with the sampling, the more replicates you could take. So for example, subsampling every 3 meters, I could take up to 6 replicates. And so with each subsample, I pulled out the metrics of interest. So I said, what was the richness if I subsampled at 3 meters or every 2.5 meters? And then for each replicate, I took basically the average of the metric of interest. So what was the average richness at subsampling every 3 meters across the different, the 6 replicates. So that's the basic design, just slicing up the transects and taking the average of whatever metric of interest was. So the first one I was concerned about was basically, do we get a change in richness with reductions in sample effort? And so this basically shows what that reduction is for the 9 different sites where we're taking these surveys. And this is showing you basically the estimates for the first round of sampling, then the second round of sampling. And this is the % reduction in richness with decreasing levels of effort. So going from half a meter, which is the actual level of effort that was used, to all the way out to sampling the transect every 10 meters. So again, at half-meter intervals all the way out to 10. Obviously, the takeaway here is that the less sampling you do, the more species you're going to miss. So we see this reduction in effort with a reduction in estimates of richness with reductions in sampling effort. So this isn't unexpected, but the question we're asking here is, can we reduce effort a little bit without sacrificing our estimates of richness? So obviously we wouldn't go out to 10-meter sampling, but can we go out to 1-meter sampling? And do we see a reduction in the richness estimates that's acceptable for this survey? So this slide is for the whole survey, or the whole transect at each site. The other question I had was, can we look at richness estimates by the vegetation zones? And so that's what this plot shows, again, going out from the true sampling effort all the way out to 10 meters, but just breaking out the estimates for species richness by the vegetation zones that we saw across all of the sites. And of course, we see the same sort of pattern. Obviously, less sampling, we get less lower counts for the species richness. So again, this is the % reduction in the true species richness that we saw sampling at every half meter. And these are all the vegetation zones that we saw at each particular site. I tried to sort of highlight the zones based on their total richness. I think the idea being that the more species you have at a particular zone or a site, the more likely you're going to see a greater reduction in that estimate of species richness with reductions in effort. You can kind of see that here. So the thicker lines show zones that have overall higher richness, the true richness with full sampling. But again, take home here is that less sampling you do, the less species you're going to find. The other question I had was, what if we reduce effort? Are we able to basically understand what elevation key species are occurring at? And so key species, this is just one example of looking at the 3 mangrove species, red, white, and black mangroves. We know that these are going to be occurring at a particular elevation at a site. With sea level rise, we might see them sort of shifting at higher elevations depending on the species. And so the question we had here is, again, if we reduce sampling effort, does our ability to estimate the elevation at which these species occur change? And so it's the same story here. This is showing basically the elevation at which 95% of these species occur, where that estimate is with a given level of effort. And so, of course, again, same story, is that reducing the effort, we see kind of that estimate change. So some of the estimates are not changing that much for a particular species at a particular site. What's interesting here is that the variance of that estimate changes. So our precision, our ability to estimate that elevation does change quite a bit with reductions in effort. And then the last question I had was our ability to look at changes in the zones. So again, if you remember, at each site, we're tracking basically not just the species, not just the trees, not just the elevation at which these species are occurring, but where these zone transitions occur along the transect. And so this is just 4 examples of 4 sites. So I did this for all 9 sites, but essentially this is the transect for these 4 representative sites, going from the shoreline all the way up into the uplands, and the colors show the particular zones. And so this is subsampling, again, going up on the y-axis every sort of half meter, so the true estimate. That's where these lines exist, going all the way up to subsampling at 10 meters. And so you'll see that these black dots and lines are essentially our best estimate of where these zone transitions occur with each reduction of sample effort. And so the take home here is that we basically lose the ability to identify that true zone with increasing reductions in sample effort. So again, not a surprising result, but this is just showing you how that ability to identify that zone increases or decreases with a reduction in sample effort. So we do have some sort of take-home messages from all of these metrics, but yeah, so here are the take-homes. Basically, reductions in effort cause us to basically have a reduction in an ability to estimate species richness, as I showed. Same for the estimates of elevations for key species, and same for our ability to identify the transitions in the zones. And this, of course, affects our ability to track these changes over time with sea level rise. And so the question is, what level of effort reduction is appropriate? Obviously, going out to 10-meter sampling is not going to work. And so I think with going from half a meter sampling to 1 meter sampling, we don't necessarily lose a whole lot of precision in our estimates. So, here's 1 meter sampling down here. I could show you the same slides for the species richness and the elevation changes. But basically what we're recommending is that going down to 1 meter sampling is okay. We're not going to sacrifice a lot of information. What that means is basically a 50% reduction in effort. So field crews are going to be happy about that, and we're not, sacrificing information moving forward. And we can discuss that decision at the end of the talk. But at this point, I want to hand it over to Kara, who will talk about proposed changes to the tree surveys.
Thanks, Marcus. So with the tree surveys, I'm actually proposing measuring more trees. So I think we were oversampling the basal cover of the vegetation, but undersampling the trees. So the method that we have been using is point-centered quarter, or PCQ sampling. And this was a method that was developed in the 1950s as a non-plot method to sample trees along a transect in a forest. So in this method, you have a given point, which is shown inside the red box in the diagram there. And you have 4 imaginary quarters surrounding that point. And then you measure the distance from that point to the nearest tree within that quarter. And then you also measure the diameter at breast height of that tree. And using those 2 measurements, you can calculate tree density, trees per hectare, and also basal area, which is meters squared per hectare. That's like the area covered by the trunks over a given area of forest. Next slide, please. So with the design that we have been using, we've been putting these measurements inside the randomized plots, which are all shown in red in this diagram here. So this results in a measurement of 3 points per zone across the transect. But PCQ, it assumes that there is a random distribution of trees. It's designed for a forest that doesn't have a gradient. So when we're making these calculations for PCQ, we do the calculations based on the zone. But when you're only doing calculations in each zone, number one, it's still a gradient, even within the zones. So it's kind of, we have to make some mathematic corrections for non-random tree distribution. And we also have a very small sample size because there's only 3 points per zone. And there's often missing trees. In salt marsh, you're not going to have a lot of trees. So you may only measure 1 or 2 trees within the salt marsh zone. So we do have a very small sample size currently for some of these zones. And it's only a maximum of 12 trees, even in the forested zones. Next slide, please. So PCQ, it's designed for use with a very large sample size. We're talking normally at least 100 trees. But in the current methods in CCHA, we're doing calculations with only a maximum of 12 trees, sometimes only 2 to 4 trees in some of the less vegetated zones. So this leads to really high sampling error, and I found with making the calculations in the past that we tend to be missing the trees that are large and occur less frequently, because if a sapling happens to occur closer to the point where your starting points, you have to measure the sapling as the closest tree, and you miss that larger tree that might be further away. And also, if you happen to capture a large tree close to that point, it can really skew the measurements due to the really small sample size. And this is just an example from Fort DeSoto from the prior rounds. And in the first zone A, that blue is showing cover by black mangrove trees. And that was largely driven by one really large black mangrove that just happened to be close to the point. PCQs assume that it's a uniform distribution of that size tree across the entire zone, and it can really skew the measurements if you have a small sample size. And we've also found that PCQ is problematic at detecting change over time, because if you return to a spot and a sapling has grown, you have to measure the sapling as the closest tree to that point, and then you wouldn't remeasure that larger tree that might be behind that sapling. And so it can lead to really noisy measurements over time. Next slide, please. So I'm proposing that we basically start measuring more trees along these transects. And I'm suggesting that we do this with a belt transect with wider belts for larger trees, because they are less common. So at the smallest tree size, I'm proposing that within a half meter on one side of the transect, and this is the same side of the transect where we're measuring the basal cover and the quadrats that Marcus was just discussing, that we measure the DBH on all trees that have a DBH of at least 1 centimeter. And DBH, that's just the measurement of the diameter at 1.3 meters high on the tree. So we'll measure all trees with a DBH greater than 1 centimeter in this area, just on one side of the transect, because on the other side, that tends to be where we walk, and there's a lot of foot traffic and trampling in that area. So we can't very easily measure on both sides of the transect, at least for this measurement. Next slide. And then for the slightly larger trees, so trees with a diameter of at least 5 centimeters, we'll measure all trees within 2.5 meters of the transect on either side of the transect. So that will be a 5 meter wide belt transect. And next slide. And finally, for the very large trees of a diameter greater than 10 centimeters, proposing that we measure all trees that are within 5 meters on either side of the transect. So that's a 10 meter wide total belt transect. So using the measurements from these 3 belt transects, we'll be able to calculate actually the same metrics that we were calculating for PCQ, and we'll have tree density, species specific trees per hectare, and also species specific basal area. So we're not only measuring the diameter, we're also measuring whether the tree is live or dead, and also recording the species of the tree. Yes, you can go ahead, next slide. Thanks, Marcus. And I'm also proposing that we start adding tree tags. So we have found this really helpful in other monitoring that we conduct. If you're returning to a site, it's just helpful to know exactly what trees you've measured. So we put out aluminum tags that we either nail on the larger trees, or on the smaller trees, we can attach them with wire loosely to allow room for the tree to grow. And this will let us know that we are measuring the same trees every time, and we're not missing trees when we return for subsequent monitoring. Next slide. And then finally, our third change that we're proposing has to do with the vegetation zones. So these were zones that were just visually assessed when we first established these transects. And you can see in the figure in the lower right there, for example, it goes from zone A mangrove to zone B Maetaenus in this case. And we just put down wooden stakes at the transition point between these zones. These zones were held the same in the 2018 monitoring. We're proposing that if we see significant changes in vegetation distribution, that we then move these markers. For instance, if the mangrove zone has expanded inland, that we move the markers and document that that zone has expanded inland. We'll still know where the original zone was, because that's based on that meter mark. So we'll still have that available for mathematical any sort of statistics we want to do. But if we want to see how zones are shifting over time, we'll need to shift the zones just by visual assessment in the field. And we'll still keep the start and stop points the same. We'll still keep the 3 randomized quadrats per zone the same, just for the sake of continuity. So Marcus, do we want to discuss this now with the group?
Yeah. So basically, we have those 3 proposed changes. We think they're reasonable, but we want to make sure we get this right because this is a very long-term monitoring effort that will, outlive our careers. So, we're putting it in front of you all to give you a chance to comment on these proposed changes, make sure that, we agree that they're appropriate and that we can move forward with the next round of sampling and so on.
All right, do we have any questions? Yeah, feel free to use the chat to post your questions. Just make sure you say to everyone so everyone can see. I don't think everyone's finished their coffee yet. We have one hand up. Just unmute yourself. There you go.
Yeah, hi Marcus, how are you doing? Frank Miller Carger here. Good morning, everybody. I was wondering how wide these zones are and how random the vegetation or the other species you're looking at are within those zones, because if it's truly random, then I don't think that you should see, if you repeat the samples artificially at different spatial resolutions, you shouldn't see a systematic decrease in the number of species as long as you're within a zone. So I was curious how you did that. I would have sampled multiple times. In a sense, I don't know, you did it by replicates. But that was my question. No? If you're still within a zone and your sampling is squarely within the zone, multiple samples, you should get on average the same answer.
Yeah, that's a good question. I guess one of the, thoughts about how to do this analysis is the subsampling design. I mean, to answer your question, the zones are quite large. I'd say on average, and Kara, maybe you can weigh in on this as well, but several meters. I mean, very few of them are small. And I don't know if the species are randomly distributed in there. When I was doing the subsampling, it's each one of those is an independent sample. And if you're just looking at species richness, then I think, averaging across the replicates would make sense. But if you're looking at, does this particular species show up, then I think that you're right, that if you do the average of the replicates, then you might see it each time. The fact that we did see a reduction in richness tells me that, that follows the expectation. The less sampling you do, the less species you'll find. And sites that had higher richness tended to have a greater reduction in richness with less sampling. So I'm fairly certain the method we used to subsample was appropriate. Actually, I was going to mention that if you want to look in this in more detail, you can go to this website here that we put together that shows, higher resolution results than what we showed on this presentation. And if you have any other questions about, the subsampling routine, maybe we can chat offline. But, like I said, the expectations were as we were suspecting with reduced effort. So.
So Dave Tomasco, Dave Tomasco's asked in the chat if there's an identified funding source for this work, and he notes that it'll work best if it's maintained for decades into the future, not just years into the future. And so, Dave, this is an action in our CCMP, and so there is a commitment to fund this work through our work plan or to seek additional funds in perpetuity. That was, part of the original project and the commitment that's in the CCMP. I suppose one could say, like, it's hard to bind future program staff or policy boards, but right now we're funding this work through our work plan every 3 to 5 years, and that commitment is, locked into a few different places so that we can ensure the best of our ability that it proceeds into the future. Let's see. Damon, do you want to unmute and speak your question out loud, or your comment, make your comment?
Yeah, I'll do that. No, I just this looks like it makes a lot more sense as far as trying to do this on the ground. It doesn't look like you lose that much. And the other thing too, and I don't know, maybe you're already doing this, but as far as like, I think you need to track freeze results, freeze and fire events as well, just because those are going to have impacts on vegetation zonation as well. So that was it.
That's a great point, Damon, because I know like this was originally conceptualized as a sea level rise kind of project, but we do know that the temperature in particular and fire regimes are important as well. Maya Trotz, do you want to unmute and ask your question? So Maya's basically asking about how much this kind of work costs and whether or not it creates jobs for the blue economy. Kara, do you want to respond to that?
Really, at the heart of this, we're interested in the fate of mangroves over time in the bay, and are they able to maintain their locations given sea level rise, or move upland in salt marshes and move upland in response to sea level rise. So it really has to relate with all the questions associated with coastal wetlands, and if they can maintain their area, successfully move upland, if they can't maintain their seaward extents. So that relates to everything with all the ecosystem services that they provide with nutrient filtration and carbon sequestration and habitat provision, of whether or not these habitats can maintain their current area.
What about cost and jobs, Kara?
Oh, cost and provision of jobs.
Yeah.
Well, I mean, indirectly related to the jobs in the bay that are related to having a healthy bay. You can see the indirect effect, but I think it's more of an indirect effect related to having a healthy bay.
So I think we're running towards the end of time on this topic, but the goal here is to make sure that there's TAC consensus that these suggested revisions to the methodology are appropriate. I think we've heard from Damon that he thinks they're appropriate. If anybody else wants to weigh in on that, that would be helpful for us. You can put your comments in the chat or provide comments directly to Marcus and Kara. But if you don't have any concerns that you want to offer right now, I think this is how we're going to be proceeding to modify the QAP for the project and what that method looks like moving into the future.
Just a couple of thoughts that I had. You know, it wasn't part of this presentation, but, you know, have we actually looked at, you know, with regard to I know the aerials every couple of years and what they're showing with regard to trends versus comparing what the transects are actually showing us. Transects are a very specific location. They don't speak to the whole area. So, you know, I've kind of had been a kind of a bug for me, is just, is that it tells you at that exact transect, yes, you go back year after year after year, but that's it. That's all it tells you. And so I would like to know how well those transects are catching what we're seeing in some of the work that, we're doing with the aerial coverage. Obviously, we don't get the species richness, we don't get the condition, those types of things with that, but at least from a coverage perspective, density perspective, is it reflective of what we're seeing across that effort? And should we be looking at other methodologies and not just being married to transects because we've been doing it this way for 30 years or whatever? I I know it's hard to let go of things when you've been doing it for so long, but if there's a better way to do it in a way that gets us more information and really does, meet the goals of the CCMP and make sure that we're really getting a good picture of our seagrass in the bay, then I think it's worth the conversation. And I do know, I can't remember what year, so I'm really aging myself here, but it was back, in the Andy Squires days and the Roger, back when they developed I think it was there was an actual technical report on various methodologies that could be used for monitoring seagrass and the pros and cons of them. And I probably have a hard copy of it somewhere around here, but anyway, I just think these conversations are worthwhile.
Yeah, that's a good point, Kelly. I think when we were originally contemplating this critical coastal habitat assessment back in around the 2014 time period, there's actually 3 tiers of assessments that we were proposing to do bay-wide. So the highest level of assessment was looking at land use changes, so gross changes according to habitats defined by land use land cover. But then there was also a middle tier that we haven't generally developed as of late. That was looking at changes in shoreline and zone according to the bay segment level, using an analysis called Digital Shoreline Assessment System. It's kind of a USGS technique looking at changes along the beach. So that second tier assessment, I've actually asked Carrie Walia, one of our new staffers, she's our restoration ecologist, to kind of explore those additional assessment tiers as we build out metrics to understand how habitats are changing in the future. And of course, the third and the on the ground tier is this transect level. So I think there's room for us to further develop metrics beyond just relying on these transect data to understand the gross changes in the bay as it relates to these critical coastal habitats. We just haven't got a chance to fully develop those other tiers of assessment yet. But they're coming.
There's one more question in there. I'll just read it. Can you do sampling both the old and new way for a limited period to understand what differences you see?
I suppose we could, but I guess that's up to Kara, who's actually going to be doing the field work, and if she has the bandwidth to do it that way. But honestly, I feel like the subsampling that we did on the desktop is more or less kind of the same thing. So I would expect to see very similar results.
And if this question is referring to the changes in the tree methodology, based on prior studies where we've tried to use PCQ to examine change over time, we really run into the issue of those saplings, pop up, and then you're supposed to measure the sapling as the closest tree. And so the data really aren't comparable over time anyways. If we were to repeat the PCQ, you're either missing the new saplings or you're missing the old trees. So we found that PCQ just hasn't worked well for change over time, period, with other studies that we have found.
Okay. All right, is there any additional conversation on this item? So we can move into the next presentation, Resilient Shoreline Model Ordinance, CJ.
Good morning, everyone. Thank you for inviting me, Ed, Maya, and Kelly. I appreciate the opportunity to talk to you about what's been going on at the Tampa Bay Regional Planning Council. So this morning, I'm going to give you an overview, and some of you have perhaps heard this before, because I think I presented a year ago to one of the estuary programs meetings about the new Resilient Shorelines Model Ordinance template. First, let me explain what a template is. As a model ordinance, it's a thing that is basically designed to reflect best practices. The Tampa Bay Regional Planning Council doesn't have any authority to pass ordinances, so we created a model for many local governments to use and borrow from. And by designing this thing with their input, with expert input, it could be adopted in totality, or chunks of it could be adopted and considered. And so I wanted to just give you that context before I got into it. So now let me see which screens I need to click on here. This one. Great. So this project has been in the works since, actually, I think when I was at Frank Mueller Karger's lab in 2016, thinking about living shorelines and coastal issues. But when I reached the Regional Planning Council, the Tampa Bay Estuary Program, CCMP, made it, that analysis that we did made it very clear that there was a lot of ad hoc variable language and comp plans, policy documents. And so from there, it built on that. We really had some strong recommendations from our elected officials. Actually, their question to me was, CJ, how high should we build seawalls? And I was like, ooh, maybe it's a little bit bigger than that. And so we began working on this to include a variety of engineers, experts. We looked at model ordinances from other states, other cities, other counties. And then we got a grant from the FDEP, and we were able to hire Aaron Deedy, who's really an expert in land use policy and environmental. We talked with a lot of folks. And then over time, having this working group met. And so just at the September council meeting, the members voted and authorized us to release this. And now we're in the sharing in the information of this document. As with any policy or like any kind of scientific document, it's never really a static thing. It's really a guide and a roadmap. And if there's absolutely things that need to be updated or changed or amended, that will be considered by the organizations and the recommendations. So why would we do a model ordinance? Well, as I mentioned, the overall variability from local jurisdictions, cities to cities, had different heights, different information. So it's really a benefit. This is about what can private property owners do? What kind of information and guidance and code and language do we need to provide to them so that they don't just automatically assume they have to put up a seawall? How can we help them understand through useful guidance that there's more types of adaptation techniques that can be used also for the counties and for the municipalities? Really look at how we can support, coastal and riverine flood reduction activities, improving, the resources that they have to draw from, and increasing consistency, and really drawing on the science that we have available for us today. And then really supporting the increased, where possible, naturalization of the shorelines, or I should say renaturalization. Sorry, I'm clicking on the wrong buttons here. All right, I have too many monitors. There we go. So summary of the key concepts, I apologize, is that really we wanted to incorporate the concept of what are the needs for elevation. We recognize that the seas are rising. Also, that means water is moving inland. So I understand the science of this, but we felt we needed to help define how tidal flood barriers, which is really the category of strategies and techniques, could be integrated in one document. And we do define parameters for height, but we did not set a maximum height. There was a lot of recommendations for like, don't go over this height. So we've established a minimum elevation. One of the key things that's in here that I think is potentially relevant and to the TAC and future research that needs to be done is building on the FWC's living shoreline suitability model. So what we've established is a principle, is a policy concept that's already used in other areas called a shoreline protection overlay district. So that exists, you already have your other districts today, but this is really to understand certain areas of the coastline do not necessarily need to be hard. And we learned a lot from working with Tom Rees. Where is the possibility to renaturalize if there's an existing set of wave, energy, depth, all these sorts of things. So establishing the shoreline overlay district as a concept, and then working on the exact type of mapping of typology and the wave energies to understand at a staff level, what is it that you can, what could be done with these areas? And so Tom did a great analysis of Treasure Island and this one area of canals and what can be done on one side versus what could be done on the other side. And by understanding these things, you have better guidance. And so we created these classifications for the categories, and we established a target year for everything. So there we go. So I'm not going to bore you with a lot of policy stuff. Actually, we'll I posted it. You probably have an attachment, but I'll put it into the chat, the link. You can download the document if you hadn't already. But the intent of this is to help ensure that local shorelines are resilient to changing sea levels and tidally influenced flooding through 2070, to provide both community protection benefits and ensure the ecological integrity. So what you're reading here is the actual language in the ordinance. So we're really driving on, it's not just about protecting property, or it's not just about the natural thing, but you can do both with the right set of strategies. And in this, at the very beginning, we establish what are we talking about? And this is going through and defining all the different varieties of implementation that you could do and how this ordinance would apply to that. And why is that important? Well, what we learned from our analysis of policy is that there's often a section that says living shorelines should do this. And then there's another section somewhere else in a different part of a code that tells them what the seawalls can do or what docks. And so the idea was to really help people see the coastal component as an integrated piece and really looking at the future, 2070. It's not just about building for today's risks and issues, which I don't even think we can when you factor in the enormous aspects of hurricane and surge as we go forward, but to really look at establishing ways to protect and preserve the natural shorelines, promoting living shorelines and hybrid ones, and defining the appropriate locations for hardened structures. Why does this keep doing this? Yeah. Sorry, Maya. Can't quite figure out my own computers here. Okay, so section 2. This is really where it talks about, this is not something that's retroactive. For example, if you lived in a certain area right now, this would not necessarily, and a local government adopted this. If you had a standard 3-foot seawall and it was in good condition and doesn't cause flooding to an adjacent property, you would not have to comply to this. So what it builds in is a series of trigger points that then will cause you to need to do something in this condition. And this was very important for a lot of reasons. But one of the new components on this is that if you fail to maintain this tidal flood barrier in good repair, or what you do allows other people to be flooded, or the right-of-way to be flooded, or public infrastructure to be flooded. There's some other clauses and issues that come into play that would help enforce that. So the minimum elevation, there was like 2 years of discussion around this, was to use 5 feet NAVD 88 to account for projected sea level rise in combination with high tides. And then this, we know the NOAA curves and scenarios will be updated by the Flood Hub. And so we put in this clause that says every 5 years. So the conversation of why 5 feet, we looked at a lot of the leading cities and counties and what they were using, how they were approaching it. We had Broward County, Pinellas County, several other cities, I believe St. Pete Beach. So the idea is to, work our way to consistency, but we don't want to be too high. That's really the point. We don't want to create bowls. And so the idea is what's the minimum elevation you can set? So this may need to be adjusted over time. The idea being, what is the life of a residential seawall in that component. So this was the shoreline district that I mentioned to you, which is something that we'll all have to work together to be established. Again, it's not one giant thing, but in the example in the regular land use planning world is you have areas that are designated as commercial districts. They don't allow, lots of homes to be built in those commercial districts. So it's appropriate use consideration. So in your existing shoreline, you would put this as your overlay. And if it's a residential area with a shoreline, you still want your shoreline protection overlay district on that to be able to assess this and see where the opportunity is. So we'll talk more about the public interest determination process and how useful that will be for local governments. So one of the things that we wanted to do, we heard a lot from people who work in permitting in the departments. We heard from contractors who have different major challenges getting projects implemented. Frequently, I heard about the difficulty of getting living shorelines permitted from a variety of experts. And so what we wanted to do was to indicate if this was your existing shoreline type or category, so you had a natural one, you could receive what we would call almost a standard automatic go forth and produce this kind of shoreline under these conditions. So if you had something that had a hybrid, was kind of, the rocks in front and something going on, we wanted to encourage you to continue to do those things. And so if you already had a hardened seawall, then to rebuild, you would have to do a lot of enhancements. And so the whole thing works its way across. So future conditionally permitted means you may have reasons to do these other things, but you're going to have a slightly more different permitting review process all the way till we get to the, well, you're natural now, but you think you want to put up a seawall. And so what is the criteria for doing that? And this is where we use the public interest determination process, and I'll explain that in a minute, which is an existing environmental permitting process already in place by the state. So we didn't invent new criteria, but we leveraged what is already there now. And so this public interest determination was a big sort of addition post to key stakeholder meetings that we had that really told us that we need a consistent review process. Staff wanted a consistent set of criteria. And so we used this Environmental Resource Permit Applications Handbook. This is a very defined set of, things need to meet these set of criteria. And it's already being used. And the idea being, when you build something, even if it's private property, your building, your wall, your shoreline component needs to be not violating or found not contrary to what's best in the public interest. And you say, well, who defines what is the public interest? Well, it's already defined. So that's why we like this. And so the aspect of the language says shall be determined to be not contrary. And this whole component that says undertakes the balances of design of the seawall and bulkhead with or without enhancements, considering future impacts, sea level rise, tidal flooding, with the benefits, cost, protection, and potential adverse impact for its projected useful life. So we'll get into that quickly. So this language, the first 7 criteria points of public interest determination, at first you see it's not going to affect public health or safety or welfare. It will not adversely affect the conservation of fish and wildlife. Will not adversely cause water flow to create erosion or shoaling. Will not affect the fishing or recreational values of marine productivity. It decides also where it's going to be a temporary permit nature. So those are straight out of the Environmental Resources Handbook. Additionally, we added these other components to, in very specifically this one. A lot of the questions we had was that, canal communities operate under a wholly different set of conditions and rules. And we said, all right, well, that we have to factor that in. We have to accommodate that because we recognize that many communities in our different counties have those narrow canals, and they're calm until they're not calm. So what we defined was that the condition of the waterway where the seawall will be located. So where is this shoreline actually at? Is the width of the shoreline wide or small? This is what we would call that resiliency factor to enable you to say why you're well there. The elevation of the adjacent properties. This was the floodplain managers have a lot of perspectives on, preventing undue or adverse impacts to the neighboring properties. And then this is really a very standard sort of planning and code and building code. The type of building that is served, or the type of property that is going to be in front of it. So, think of downtown Tampa. If you're building, multi-million-dollar, or you have a high risk thing like a hospital or whatever, you can potentially cite different needs for different kinds of risks, either vulnerable populations. So we haven't tested this yet. That hasn't been brought to be like, what's the pro and cons of each of these, but we think this allows the flexibility for staff to make the determination in the best interest of the community. Also gives the contractor or the developer some parameters to understand. We would say that everybody should have enhanced seawalls. Even if you think you have to have a seawall, there has to be enhancements in front of it. So those are the new big things in these categories. The next part of the ordinance provides a description, a paragraph of what are natural shorelines. We used a lot from, I spent like days talking to the National Wildlife Federation, reading their Softening Our Shores books, Fish and Wildlife, just lots of time connecting with other experts in the region. So the natural to the hybrid to the seawalls and the bulkheads, it is not a design manual. It does not have details of what type of plants or what kind of concrete or anything like that. That's really the next step. But this is important for a start, a baseline for us all. Of course, in terms of government components, you have to have categories that allow determined people, staff to change and address things if there's a hardship. So there's a category in here to allow for specific, if I'm like, I just can't afford this, what can I do? And so this is allowed in that. Application for permits, this follows existing code procedures. We had some deep conversations or extensive circular conversations about expenses. In many cases, in property component, if there's more than X percent damage, then that triggers a set. Or if the project is cost more than X, that submits it to another set of things. But this one was quite complicated. We'll be eager to see how this plays out. Although we did do, Tom Rees's group helped prepared a linear foot cost analysis. So we have a really interesting spreadsheet of projects that list, based on X number of feet, what a totally natural shoreline to a completely hardened and with enhancements in front of it. So we're really wanting to understand the cost of construction. And then there's, of course, the natural thing that includes maintenance and operations. Anything you build, you have to maintain in good use. And then this also, if you don't, then it triggers other things. And this is definitions in there to indicate what do we mean by a tidal flood barrier that's in disrepair. So that's helpful, again, to a property owner. Notifications. This may seem obvious, but we felt that as you start to define these expectations for property maintenance and expectations for improvements that need to be made to a property, that it should be included in your real estate contract. Now, local governments have the opportunity to put this as a requirement. We also are talking, one of our chairs is interested in taking this to the state level, because it's just a common sense kind of thing that says, this real estate is located in a tidally influenced area. You as the owner may be required by such ordinance to meet certain requirements. And it's not much different than what we have that says if you buy an old house and your electrical wiring was back from 1960s, you're expected to bring it up to code. So this is the conceptual clause that's actually very productive in helping people understand, if I buy this thing, I have to do something with it because it's crumbling, but what can I do? Can I go to a naturalized or some sort of softened front edge or enhanced front edge with that? So it's just a clarity of understanding of your responsibility as a shoreline owner. So that's the quick summary of it all. And so as I mentioned, that the council members have heard over 2 years, we've probably had 6 presentations to our council members. So they have had many discussions. We've brought in contractors. We've talked about shoreline. We've had all kinds of like, what if this or that discussion. So it's really been, we've really raised the level of awareness for the need for integrated policy to address shorelines. We're going to do a rollout webinar. We have lots and lots of contractors signed up for the webinar to the wide group on next Tuesday. I'm sending invitations to individual program staff. If you're on program staff somewhere, you would like to, you can't make it to it's the 25th. Sorry, I said Monday, I meant Tuesday. And so if you can't make it to that, but you think it's an important review process internally for any of your committee, we're offering meetings to do a deep dive into specific aspects. We don't have the staff bandwidth to like do code analysis for yours or theirs, but we can eyeball things and kind of see like, where are you at today? How can this benefit you? Whether you take a whole section or you take subsections of it, right? And that sort of thing. Have staff in Hillsborough County and this engineering side and planning program staff has been very excited and supportive of this. So we're hoping to get moving on that. So, I mean, the other thing that's possible is that, you know, we're reaching out to say if you think that it would be valuable to present to other official environmental committees, councils. We need to, this is, you know, like we said, we don't pass the rules. We encourage our members to use them. They're excited about this, but now we need to keep, it takes time and it takes commitment from staff to move these things forward internally and then to take them to the board. So while we still have support and excitement and they remember what this is, we would ask you if there's ways that we can leverage your contacts and networks to move forward in making those presentations. And then the next steps would be, it's actually part of our regional resilience action plan, is to reactivate the Resilient Shorelines Working Group. And I would love to talk to Maya and the team about how that might look, what the collaboration might be on these things. And this is really to get to the level of producing design and construction manuals and standards. And there's a lot of those from other areas. As I mentioned earlier, I did some research. I wanted to bring in the, you know, back in the day, the people from Seattle had a great program for developers. We know there's the Florida Marine Contractors program that Farah created before she went to the Northeast Planning Council. So there's a lot of materials that are there for background resources that we should hone and refine. So it really makes sense for the counties in the Tampa Bay Regional Planning Council or even the coalition. For those of you who don't know, the Resilience Coalition, Sarasota County and the cities and along the Barrier Islands, there are also members of the coalition. So thank you for letting me present to you. And if there's time, I'd be happy to take some questions and stop sharing. And I apologize that I couldn't figure out how to use my mouse before.
Thank you, CJ. Do we have any questions?
I think CJ accidentally left the meeting, so I think we should
Oops.
let's just move on. And if you have questions or comments, we can deal with that in the chat.
Okay. All right. With that, we're moving on to a presentation by Don Anderson with Woods Hole on the control of red tide blooms with clay flocculation, a pilot study.
Don, I just turned over presenter controls and we can see your screen. Let's see when you go into presentation mode. Perfect.
Okay, great. Well, thank you, Maya and Kelly. First of all, who am I and why am I here talking to you all? I'm Don Anderson, and I'm the lead PI of several projects, and you can see here the various co-PIs from Mote Marine Lab and Christy Lewis from UC Central Florida and the University of South Florida, Kristen Buck. And these are two projects that are addressing possible methods for controlling red tides. And the reason I'm talking to you is that one of these projects is funded by what's called the NOAA PCM HAB program. That's called Prevention, Control, and Mitigation of HABs. And HAB meaning the same as red tide. And one of the ways, when that program was created, everyone recognized that people would be working on potential control or suppression, bloom suppression strategies. And they could easily do all this work in the lab and then show up and say, all right, we're ready to put it in the water and try it. And all sorts of stakeholders and agencies and others would not be prepared or probably receptive. So the idea, we created what's called a Transition Advisory Committee, and Kelly is on that committee. And part of the concept is to, right in the early stages, to talk to as many stakeholders as possible, let them know what we're intending to do, and to seek guidance and criticism and just whatever about what is happening, so that when we get to the point where we might be proposing this to become operational in some sense, people have had a chance, the ideas have been vetted, and that people have had a chance to comment and learn about it. So this is a step in that direction, since it's quite possible that some of the small scale studies that we are funded to try to do will happen in the Tampa Bay NEP, and potentially even in the longer run that some much larger scale study or just actual mitigation efforts might happen there. So that's the background. I'm basically looking for advice. And I should add one more comment, which is that times really are changing with respect to technologies for trying to control red tides. There's a good bit of funding nowadays going into it, and I'm quite sure that I'm not the first effort that you will hear in the coming years about people with interesting strategies. And so it's there's a lot of issues that come up: environmental impacts and logistics and media outreach, communications, and everything. So it's something for you at the TAC level to be aware of. Okay, so I don't need to tell anybody down in Florida about your red tide. It's just a massive and destructive phenomenon. What I do want to highlight, though, is that in the field of harmful algal bloom research, work on controlling blooms has been very, very slow. We've made tremendous progress in so many other areas, but actual control of blooms or suppression of them is really languishing. And this is a commentary I wrote in Nature. You can see back in 1997. So it was a long time ago. And I'll just, this quote, for those who may not be able to see this or are listening, is from that commentary. I wrote that the problems we face with HABs are similar to those encountered in agriculture or medicine, fields in which control of pests and disease is a practical reality. The marine environment is admittedly different, but our hesitancy to pursue bloom control strategies reflects a de facto acceptance that the problems are insurmountable. I believe they are not. Now, you can see that was, what, 25 years ago, and have we been able to control any red tides out there on any sort of scale? The answer is no. Things are progressing more in freshwater systems, but in marine environment, it's been slow progress. So, but right now, we have funding in a couple of programs. One is called, the one I mentioned, PCM-HAB, which is a NOAA program called Prevention, Control, and Mitigation of Harmful Algal Blooms. That's a national funding initiative, has gotten renewed money in recent years. But also there's the Florida funding for what's called the Florida Red Tide Mitigation Technology Development Initiative, or I think it's the MOTE, Red Tide Mitigation and Technology Development Initiative, and that's being coordinated by MOTE Marine Laboratory and with funding through the Florida Fish and Wildlife Conservation Commission. And I could add that there's a lot of money now from the U.S. Army Corps of Engineers to deal with freshwater bloom control. So there is money going out there and new projects, and we have funding from those two, from the PCM-HAB and then the MOTE initiative. And let's see, for some reason, this doesn't want to advance. There we go. So I want to give you a quick background about what's out there in terms of control methodologies, very, very quick, and then focus on what we intend. There, you can break down control into three different categories. You can use chemicals, you can use biological organisms, or you can try physical control. I'll try to explain briefly what those are. The best example of chemical control is what happened right in your area, long time ago, 1957, when they used, somehow I lost, there we go, where they used copper sulfate, a very broadly lethal compound, and sprayed it over, as you can see, this 40 square kilometers, 16 square miles. They did this during an active red tide that had 10 million cells per liter, so pretty much similar to what you can get these days. And they did it with crop dusting planes and dragging bags, burlap bags behind ships. And this is just such an old figure, but it shows that the red tide numbers dropped dramatically with the treatment. And then maybe a week or two later, there was a sort of a gradual recurrence, but nothing like it had been. And the method was certainly deemed effective, but it only provided this temporary relief, but it was also considered expensive. Although these days, if we could spend $1,000 to treat a square mile, I would jump at it. But it was the collateral damage that this copper sulfate killed many things at all levels, in the water and down at the bottom. So it ended it. So chemical control pretty well stopped there. And there's a few other folks out there working on different kinds of chemicals that might work, and some of them you can think of ozone, or you could think of various algicides that might be appropriate. But the truth is that we have not yet found what I would call a magic bullet. And I use the analogy with this image on the right, where you can go out and put this material on your lawn and it keeps crabgrass, or another one will keep dandelions from growing, but the grass will still grow. So even though they're all plants, there are chemicals that can target specific pathways that are unique to the pests that you're trying to get rid of. We do not have that yet in the HAB field. So basically, in the near term at least, there is no widely accepted or strong strategy for chemical control of HABs. On the biological side, I could talk for an entire hour on this, but I won't. There are many different biological approaches that are possible with parasites or viruses or bacterial pathogens, and a number of them are very either host specific or species specific. So you start to get that magic bullet type of precision here. But there still has been very little progress here, and really still no major tests of biocontrol in the field on the scales of 1,000 square meters or something like that. Not yet. And among the concerns are, imagine someone says, I'm going to go drop this virus into the water of Tampa Bay. You can imagine the kind of concerns people would have about trying to prove that it's not going to affect organisms other than the one that it's targeting. There's logistical concerns about how do you even grow and produce enough of the organisms you want and disperse them safely and so forth. So for a number of reasons, that's also been lagging in terms of progress. The one area globally where there has been actual large-scale application is what we are trying to use now in Florida. And that's the removal or destruction of cells using clay, plain old simple clay. And it really does, to this day, remain the most practical, it's proven and scalable marine control strategy to date. But as I'll show you, there's still a lot we have to do to make it acceptable in Florida on the Carenia red tide. So how does it work? Well, you can see here in this image, if you have a boat and you spray a solution of clay, which is consisting of tiny little particles, when they get into the seawater, they aggregate with each other and with red tide cells, and they become heavy and will sink and will carry that bloom to the bottom, and in some cases even destroy the cells during that what's called flocculation or aggregation process. Now, years ago, this was a good 15 years ago, I did some studies. I had a graduate student working on this, and we tested all these different kinds of clay against Carenia. And you can see, you'll hear me talk later about yellow Loess. That's a Korean material that you can see it's very inefficient. This is how on the x-axis, it's how much we've added, and the y-axis it's how many cells, how efficient was the removal. And you can see this Korean clay that they use tons of it every year. Not very effective. And then up here you see all these different clays, and then even kitty litter. And then notice way over here, this phosphatic clay. Now you all probably know well what that is because it's a byproduct of your phosphate mining, and it was incredibly effective at removing Karenia brevis cells. You can see down at as much as 1/10 of a gram per liter, I'm sorry, 100th of a gram per liter, we could remove 90% of the cells. So we sort of naively, being not from down there, worked on it for quite a bit. You can see here we did even a small study in Sarasota Bay, releasing this clay and looking at its dispersion and its removal. And we did a lot of other studies, and basically all of the work was very promising. It was very effective, but that came to a very screeching halt in large part because we had very strong opposition from environmental groups. And you can imagine now why that would be, because it was the type of clay that we were looking at, which has a horrible reputation in Florida. Nobody likes the company now, Mosaic, that produces it, or had a different name back then, but and everyone worried about radioactivity, contamination, all these other things. We were told we'd be sued if we continued this kind of work. And part of this lawsuit that was threatened was that there was what I believe was poorly informed environmental knowledge with a real focus on nutrient reductions as the only acceptable strategy. What I mean here is that every time we talk to people, oh, we're using this potential approach to control red tides, there's quite a few people out there who say the real problem is nutrients from agriculture and big sugar, and if you don't stop that, then you're just treating the symptoms and not the source of the problem. And we were told that it was basically going to be a waste of government money to try to work on these other approaches. And I won't go into details about the arguments on the other side of that, one of them being just that if you try to control nutrients in a watershed, you're talking about decades of effort, and people need some things that are going to work now. And there are many who believe that nutrient source from agriculture and land is only a small fraction of the nutrients that Karenia uses to make its red tides. So meanwhile, though, over in South Korea and in China, they continued to work on the clay and to improve its efficiency in the manner in which it's being dispersed. In Korea, they have 7 different vessels of the size you see here. In China, that many or more. That treat their blooms. This is kind of an old figure. I've not been able to get new data, but it does show you how many. These are tons of clay. So 250,000 tons of clay being dispersed in these different years to protect what's around or was around $1 billion fish farming industry, and very effectively. And in terms of environmental impacts or just conclusions from that work, first of all, there's an interesting quote here from that study, which is that numerous HAB mitigation, having trouble with the, let me see if I can move there we go, the control box here. So numerous HAB mitigation methods have been examined in Korea, including yellow clay, that's the one I mentioned, marine bacteria, microscreen filtration and ozone, UV radiation, parasites, microzooplankton predators of bloom species. Nevertheless, no other control methods have been used extensively in the sea except clay. Due to its effectiveness and practicality, clay dispersal has become a part of Korea's management scheme. So that shows you they've tried many, many things. They came back to clay. So what the Chinese did, they then have adapted this method and improved it dramatically, and it's their clay that we are working with in our studies. Natural clay, you can see as layers of silica and aluminum, and there's a certain charge to them. And in fact, the algal cells, the red tide cells, have a similar negative charge, and you actually get repulsion. And so you need large amounts of clay to get this flocculation to occur. And what the Chinese approach is to modify the surface of the clay with an environmentally safe polymer. And the one they use is called polyaluminum chloride, PAC, which is used a lot in freshwater lake restoration and drinking water clarification. It is very, very safe. It has the amount that's approved by the EPA and others for use in water is about 1/100th of what we have in this formulation. So it's just an inorganic polymer, but what it does is two things. It changes the surface charge of the clay so that's positive. So now you've got attractive, you get much more aggregation and flocculation of cells in clay, but it also, all these little chains that are the polymers bridge between particles and create a net. So that diagram I showed you earlier changes. Now you get add the clay and you get these chains almost like a net. So not only are you gathering cells here, but as this material falls, it sweeps through the water and removes cells and carries them to the bottom. So it's much more efficient. Basically, the Korean clay, they are using as much as 400 tons for a square kilometer, and then the Chinese clay, it's 1/100th of that, and maybe 50 to 100 times less. So this obviously dramatically reduces impacts and costs. So in terms of environmental impacts of all these studies, people have done this, so many papers out there looking at the water column, aquaculture, looking at the benthic community. And I just have a couple of references here. If people look at the slides and get them, you can look these up. These are reviews that give a great deal of information. In China, a quote would be, modified clay does not harm non-target aquatic organisms and has no negative impact on water quality of the benthic environment. That's after many, many studies. Korea, they have been assessing impacts since 1998, and they're not seeing any significant differences in all of the species composition, biomass, or health of all these different organisms, benthic organisms, between the areas of clay dispersal and control. And in the US, the EPA group did a study of clay and basically said that the combination of clay and the Karenia cells and this coagulant, which is a polymer, when settled over natural sediment, were usually as toxic to the benthic test species as K. brevis alone. So what that's meaning is that if you have Karenia brevis, you had impacts on these organisms. You add clay, you still have impacts, but they're no worse than with Karenia alone. So it's, and that's an important thing. Sometimes we are told we have to compare the impacts of something like clay against a pristine or perfectly unaffected environment, but that's not a fair comparison. You need to look at the effects of clay versus the no treatment option, which is therefore the effect of the red tide itself. Okay, so what we have now gotten a year or so ago is a 4-year project funded by NOAA through this PCM-HAB program. And our goal is to assess the effectiveness, environmental acceptability, costs, and scalability of this clay as a bloom control strategy. And I won't go through all of the different elements of that, other than to point out that why I'm talking to you is here. We plan to conduct field trials using a tiered approach at increasing scales and across different ecosystems. And I'll show you a little bit about what that means. So what we plan to do is to use this polyaluminum chloride modified kaolinite, a very simple clay. And as I said up here, it's widely used. It's been used for a couple decades and large scales. I didn't mention that. In Korea and China, they've done this as much as over, let's say, 100 square kilometers or 30 to 40 square miles. So it's been used over big areas, but it's not yet accepted for use in the US, and largely because most of the work they've done have not been conducted with organisms that produce neurotoxins like brevetoxin. And some of the studies have been just in flasks and so forth, and they really haven't looked at the natural communities that live in bottom sediments. So that's what we plan to do, whether the MOAT project is looking at mesocosms and so forth, and we're then talking about doing pilot studies on the order of less than 2 acres in canals and bays. So the MOAT work has had a number of different results so far. They've been done in, first of all, down here, small aquaria with crabs in them, with 80-liter tanks. We haven't yet done this, but there are plans to use what are called limno corrals, or floating bags that hang down to the bottom, and then these mesocosm tanks that hold roughly 1,500 liters, and you can have benthic communities and so forth. So among the results so far, we in these tank studies, for these blue crabs, there were no significant differences with mortality or reflexes or mortality between the treatments, and we actually showed that the crabs were able to withstand quite high levels of brevetoxin. In these 80-liter tank studies done at MOAT, these clay loadings were able to remove, as you can see here, 90% or more of the cells in just a few hours. If the material was resuspended, you can see that the cells did not survive. They did not come back to life with resuspension, as might occur with a tidal event or something. But notice that in this case, brevetoxins decreased about 75%, which was great, but they gradually increased over time. And this, as I'll tell you in several other slides, everything's been growing really well. But one thing that isn't as good as we would like is that we are not removing as much toxin as we had hoped. We're removing cells, but the toxin looks like some of it's being released into the water and is not being scavenged as we had hoped by the clay. In the mesocosm tanks at the MOAT mesocosm facility, we've done many different experiments, some involving as many as a dozen of these big tanks, big complex experiments. And you can see we've dropped Karenia abundance by 94% in 24 hours. Notice here the brevetoxin in this case was decreasing around 40 to 50%. And we were looking at urchins, at clams, and at crabs again. And clams, we had no mortality. Urchins, just a few, but not statistically different between controls. But in the crabs, there was some loss of the crabs. But when we looked at it closely, unfortunately, none of these crabs had to be purchased from markets because that was also a time where there was a red tide going on and we couldn't get crabs that were already exposed. So these market crabs, many of them had this black gill disease, and the clay treatment got an overabundance of diseased crabs, and so that study has to be repeated. So there were a number of other studies that I'll just skip through, but they've all been generally very positive. So we have twice now done these small scale pilot studies, which are going to be the objective of this new PCM HAB project. This one, you're looking down on the Sarasota Outboard Club, which is right near MOAT Marine Laboratory. It's a perfect place to do these kind of experiments. You can see we could put a boom across here. We could work from these little piers, have a control area. And notice all this we did in December 2018. And notice all the parameters to be measured: salinity, pH, dissolved oxygen, turbidity, chlorophyll, cell counts, other phytoplankton species, bacteria, zooplankton, toxins, all these chemical parameters, turbidity, COD, nitrogen, carbon, so forth, heavy metals, especially to look at aluminum as a possible release from that polymer, and then benthic impacts as well. So a lot of different things were measured. And this study highlighted, though, the challenge in doing these, because there was a red tide. We got everybody together. We got planned. We were waiting for permits from DEP to allow us to move in there. And when we got the permit, we scheduled this experiment like a week later. And in that week, the bloom disappeared. And we still ran the study, but Karenia had basically gone. And this is what it looked like, with a boom across the canal, people working, sampling from these docks and doing a lot of different types of analysis. This is us spraying the clay into this little area. And then we had what we'd call an opportunistic study that happened July last year. Again, in the same area, our permit exception was still valid, so we could do it. And there we actually had a real red tide on the order of 4 million cells and discolored water. And so on very short planning, we ran an experiment there. And you can see that the clay dropped the Karenia concentration by around 75% in just 2 hours. Notice that during that time, we had a very curious manatee that swam under the boom and into the enclosure, and everything had to stop until that manatee left. It was fine, but it was just disruptive. And in that case, then we verified that this very small amount of clay was effective in decreasing the Karenia abundance. And I say this is a very important finding because the Chinese claim has been remember I said it was 100 times more effective than the Korean clay and in the field conditions, but we need to verify that in Florida, and that's what we did. It actually was effective. But despite the high cell removal, brevetoxin concentrations only decreased a minor amount. So that, what I mentioned earlier, is still a problem. So, and if we look at what's happened so far, we consistently see high Karenia cell removal with relatively small amounts of clay. We did one field study that actually showed that a very low level per square meter was effective in removing a lot of cells just in 2 hours. And typically we would have repeated that treatment, but there was, because of the timing of it all, we only did one treatment. A second treatment would very likely have brought this down to 90, 95, or even 100% removal. We saw no significant differences in all these different studies in animal mortality, physiology, or behavior in these different treatments. Nutrient concentrations have remained relatively unchanged, except for phosphate, which actually decreased significantly with the clay treatment. And in most of these experiments, brevetoxin removal was not as efficient as cell removal. So that suggests to us toxins being released during that flocculation and sedimentation process. So we would argue that high cell removal and moderate toxin removal is still a very positive result, because you've stopped that bloom. It will not continue to grow and move around and damage the environment over weeks and months as happens. But we still would like to do better. And so we're looking at ways to modify the clay so that it either destroys or captures the brevetoxins without affecting cell removal. So we are now testing new clay formulations, and we'll be looking at that in small tanks and mesocosms. But we also then are scheduled to do these pilot scale dispersal treatments. And so what are those going to be? What we're doing is we're going around the West Florida area and identifying a dozen or more, probably 20 at this stage, sites that might look like this one. This is one that we're very keen on. It's called it's the Admiral Farragut Academy. And you can see why we like it. Here's this beautiful little embayment where you can easily put a boom across the mouth here. And another important thing is that the only abutters are the school, which is very keen on having us do this work as an educational activity for their students and such, and this one house here. And they are also very keen on having us do this because they've had dead fish and other things in this lagoon, and it's been very bad. So, but it's only got two abutters, and they're both in agreement. So what we're trying to do is identify these sites that have these types of features. We're doing site visits. We're filing permit paperwork with DEP. And we are also, as I said, looking at these new formulations. So within your region, here are a few of the areas that we see as potential sites. And I won't go through all of them, but just to give you an example, here's this, well, you know it better than me, Jungle Prada Park. And you can see it has some of the features that we need. It is accessible by vehicle, foot, or by boat. We can have access from both sides. We would, in this case, we'd have to bring in generators. It has shelter space for equipment. We need to bring our own water. It's accessible to the public. And then what kind of embankment, what kind of access do we have? You know, is it a suitable site? And we've done this for a number of these places. Here's one for the Fort DeSoto. Again, you can see different pluses and minuses. Here's our spreadsheet showing just some of the properties that are in this case, Sarasota and Pinellas counties. Notice all the information we've collected, including out here, the frequency of Karenia brevis impact. So how often do these areas get hit by the red tides? And some of them get it nearly every time a bloom occurs. Other times it's either unknown or it's medium impact. So we're collecting all of that information. So finally, where do we really stand? Many of you might wonder about scalability. There's no question right now that where we stand now is this is already an appropriate measure for canals and small embayments like you see here. You know, it's almost, to me, I view the cottage industry springing up someday where people would come out and treat a canal the same way they might mow lawns and so forth for a neighborhood association, and be able to keep that be a livable environment for people that want to use their backyards or their decks. So we're already there. I don't see any problem really doing that as long as we could get the approvals, the permits. But large open water treatments are certainly possible. That's being done elsewhere, but it's going to require multiple vessels like you see here in China, you know, or maybe a different approach. And we're even thinking, and the Chinese are testing right now, the same approach you do for spraying mosquitoes, but in this case you could spray the clay and cover large areas potentially much more cheaply and effectively than you have with these vessels. And I won't go through the costs because it's going to vary a great deal by the scale and the labor involved, but this is one of the cheapest of all of the control strategies that are out there. So that's it for me. What I'd like to ask, normally I would say I'm open for questions, and I am, but I'd also ask you, you know, what should we be measuring? Is there anything that we are not measuring or studying that we should? Are there impacts that need to be assessed that we aren't? I mean, I'll give you a couple. For example, I'd love to assess the impacts on manatees, but you need to tell me how to do that because they're protected, and other than having one swim into our treatment area by accident, that's a hard one to get to. The same with coral. We want to test coral, but that's going to be a little problematic too. So we're also looking for suggestions for good sites for pilot studies. You see the criteria we're looking for, the minimum number of abutters, because every abutter has to approve what's going on there. So a canal would not be a good one with 50 houses on it, but other sites might be. And is there other help or support that you might be able to offer us going forward, and guidance just about how it's best to approach the public, the media, and so forth? We're trying to be transparent and open. We think we have something that can help, and we're at the stage of trying to test it at a fairly, you know, a moderately large and visible scale. And we don't want it to have the kind of just, I don't know what the right word is, just very vocal and aggressive environmental opposition we ran in years ago with the phosphatic clay. So with that, I will stop, and I'm happy to take comments and questions.
We have a number in the chat. So let's see.
Hey, Kelly, this is Brendan Myers with the U.S. Fish and Wildlife Service. Do you mind if I go ahead and ask my question?
Yeah, please go ahead.
Hey, Don, has there been any coordination at all with the U.S. Fish and Wildlife Service at any level of this before the study was done down in Sarasota?
That's a good question.
I'm hoping the answer is yes.
Yeah, I honestly wish I could say yes, but right now I would have to say I don't know, but the process we went through, we worked with FWC, the Florida Fish and Wildlife, and they were the ones working with us and filing a state the state applications with DEP. I was taking guidance as to where we needed to get permits. So
Sure. Yeah. So
the answer is we didn't have to do it, I guess, and perhaps didn't, but would welcome what you would like to suggest.
sure. So my suggestion would be probably not discussing that there was a manatee that came into your research area in future presentations. If you didn't coordinate through U.S. Fish and Wildlife Service, that would be one. The second would be to coordinate with us as soon as you can. And I don't know if you coordinate with NOAA NIMS as well, but Mark Ceramics in this meeting too, and we can coordinate offline. But I would highly suggest that you coordinate with both services before you continue implementing any other parts of this research in the wild. That would be my advice.
All right, thank you. A couple things there. As I think about it, I know that Matt Garrett, who's been helping to lead this, unfortunately though he's away for a couple months at FWC. I do believe actually that he is talking to people at Fish and Wildlife, because I mean, this whole manatees issue has come up because virtually every single site we have chosen would be you would say, well, maybe a manatee would show up there someday. So we have worried about this and have started in the newest. We right now have some paperwork in with DEP, and we're talking with them about what we need to do to get clearances, and I presume that will be part of it, is to also deal with U.S. Fish and Wildlife. And I didn't think about National Marine Fisheries, but yes, them also.
So going through FDEP most likely will not involve the service. There's two separate processes that take place. One is through the state and one is through the federal side. So as you know, manatees are protected under the ESA as a threatened species and also under the Marine Mammal Protection Act. So we need to coordinate through that. So I already talked with Christy Smith privately. So my suggestion would be offline coordinating this with the service. Probably both services would be good.
Okay.
Yeah, I'm here. Hey, Don, I'm here. It's Christy Lewis.
Hi, Christy. Yeah.
Yeah, I've been answering questions in the chat earlier. And so I've been working on the permitting. And I think one of the big challenges in this project is that this is the kind of first time, we did it 10 years ago or so, Don mentioned, but we are permitting now. And this is really great input in terms of the federal side. We got a lot of course, push on working with FWC and Florida DEP. So we have just put in Army Corps of Engineers. So we are at the federal level. So we just received a new permit in the same study area that Don answered or showed you all. But I think that, Brendan, your input is really important because the manatees are a concern for all of us. I'm an ecologist, so I know that. So I'm going to reach out to you and Mark to talk about this and some of the other work that we're doing. There's one more study that was funded by a Florida Sea Grant, and that one is Don is also on that as a expert. And so we're going to be working on this over the course of the next few years. And so this insight is really helpful, and we really appreciate. But I just want to say, Don's questions about what do you need to know, what makes you as constituents in the system, what scientific questions do you want us to answer? And that's really why we're here. So thanks so much for taking the time to listen to us.
Okay, Maya, we have a lot of questions in here. I think it's great. I'm just concerned about the rest of the agenda. So how would you like to proceed?
So I just messaged you. We can have about 5 more minutes for conversation. If folks think that would be useful. I'm also volunteering if people have responses to the questions that Don has posed to the TAC or other comments that you would like him to consider. If you send those to me via email, say by like next Friday, I can collate them all and provide those written responses from the TAC to Don directly. Like I said, I think we can spend about 5 more minutes talking about this, but then we really do need to move on to the next talk.
Okay. I'm just gonna, there's some responses in here. A lot of marine mammals. Do the cells,
Jim,
sorry, do the cells die once they sorb onto the modified kaolinite?
Thank you for asking that question. It's an important point, and there's a related one as to what happens to the toxins that are carried down with those cells. The answer to the first one is yes. It looks like the cells die. Not only, as I've showed you, if we do some resuspension, the cells don't escape and start to grow again, and therefore, whether they're dead immediately or die through time because the clay is attached to them, they definitely are destroyed. Now, the toxin, that's one of the biggest questions we have, is what is the fate of the toxin that goes to the bottom? And I know some people would say, oh, this is terrible, you're going to kill all these benthic organisms. Well, the little story is that years ago when we tried to do this study that I showed you with the phosphatic clay, we were trying to find a control site where the benthic community was healthy, and we couldn't find one because the red tide had killed everything on the bottom already. So it's important to recognize that, yes, there could well be toxins that are still biologically available coming down to the bottom, but this is a sort of a one-time deposition. There won't be for weeks and months continuing raining of material down from the bloom as it's sitting in the surface waters. And we also do believe that some of this toxin is being degraded by microbes, is being broken down, and is being sequestered. And those are all questions that we are trying to address scientifically. So as much as it's a concern, I don't think it's anywhere near as much a concern as you might think, because of those factors, that we've destroyed the bloom, we've traded a one-time event with a continuous lethal event over time, and we also have strong likelihood that the toxins are sequestered and biologically broken down. So, but we're working on it.
Okay. I'm trying not to go through the ones that are already answered in here. I think it's important to differentiate between cell concentrations within the water column and at depth, as cells are rather being displaced to the benthos versus being removed.
Well, that's pretty much the same thing, but that's ignoring the fact that the cells are being removed from the water column permanently. I mean, these cells will divide once every 2 or 3 days to produce new cells, and that's one of the reasons when you've had red tides that have lasted longer than a year. You've had experience with that down there in personally, and so yes, you may displace some of this material to the bottom, but if you've done it right, you can keep an area free of that for an extended period of time afterwards. And that's a trade-off that you will have to evaluate. And we will try to provide you with the data and with our best estimates of how effective these things will be over what areas and for how long. But to me, that trade-off is worth it. And for those who talk about nutrients, we could have a discussion forever. Just remember, there are people who don't want to wait decades for not only watershed controls, but for all the legacy nutrients and the sediments and so forth to be depleted that are fueling some of these outbreaks. So there are people and agencies and groups who would like to see some mitigation during these events.
Okay, thank you, Don. We do need to move on to our next presentation. There is still quite a number of comments in the chat. I'm sure TBEP will be compiling all of those and we'll share them out with Dawn as well as the group. And then when we get the responses back, I'm sure we can ensure that everyone gets those. And if, you know, and I would say given, you know, the level of interest in this topic, maybe Don and his team could come back to another TAC meeting to keep us informed.
Be happy to.
Okay. All right. Well, thank
Sounds
you.
good.
So we're moving on to the Tampa Bay Net Ecosystem Production, 1976 to 2020. Ray and Maria from Penn State joining us today.
Morning. Can you hear me?
Yes, we
Great.
can.
Yeah. Well, thanks very much for the opportunity to present our work about carbon and oxygen cycling in Tampa Bay. A lot of this work was done by Maria Herman, who's on the line and could answer any detailed questions. It's part of a larger NASA-funded project to study carbon cycling in estuarine ecosystems, particularly subtropical ecosystems. We've conducted a study about Biscayne Bay, which we published a couple of years ago, about kind of oxygen cycling and net ecosystem production in Biscayne Bay. We had a remote sensing paper come out about primary productivity in Tampa Bay recently. What I'm going to talk about today is net ecosystem production in Tampa Bay, exploiting sort of wonderful, long, detailed time series that you have, that you've worked so hard to create. These monitoring data, they're very valuable. They give us a long view of how estuarine ecosystems behave when they're subject to long-term changes in climate and land use and all sorts of things. So what is net ecosystem production? I'm not able to share my slides for some reason, so Maya's handling this. I won't be able to use my pointer, but I think that'll be okay. Net ecosystem production is really a very fundamental characteristic of aquatic ecosystems. It's the amount of photosynthesis that's occurring minus the amount of respiration that's occurring. And I've put up here on this slide the most basic kind of chemical representation of photosynthesis and respiration. So photosynthesis, of course, consumes CO2 and produces organic matter, and oxygen, and respiration does just the opposite. When we have a net autotrophic ecosystem where photosynthesis exceeds the respiration and the NEP, net ecosystem production, is greater than 0, then our system is a net producer of organic matter. Oxygen and pH would be relatively high in that case. And in general, that's not always, but in general, the system would be removing carbon dioxide from the atmosphere. A net heterotrophic system, which actually characterizes many estuarine ecosystems, the NEP is less than 0. There's more respiration than photosynthesis. The system is consuming organic matter, producing carbon dioxide. It's consuming oxygen, so oxygen is relatively low. It's producing CO2, which drives the pH down, and the system is generally a source of CO2 to the atmosphere. So NEP is a very fundamental, basic characteristic of the biogeochemistry of any aquatic system, including estuaries, and we want to know what it is because it tells us a lot about how the system is behaving. So here's a plot. This is from my collaborator here at Penn State, Maria Herman, work that she did where she synthesized NEP from multiple estuarine systems. So each dot on this graph is a different estuary, and it's showing how the NEP varies based on the kind of material that's coming into the system, mainly from rivers, but also from tidal wetlands. And it turns out, and this was work first pioneered by Mike Kemp, who passed away recently, a great estuarine biogeochemist and ecologist. And what he'd shown in earlier work and what our work following up supports is that NEP scales with the ratio of the inorganic nitrogen to the organic carbon coming into the system. It makes sense because inorganic nitrogen stimulates photosynthesis and organic carbon stimulates respiration. So we would expect a relationship, and indeed, that's what we see. So this provides some of the context. And you can see some estuaries, many estuaries are net heterotrophic. You see the values are negative, and some estuaries are net autotrophic. So you can go to the next slide, Maya. And so we want to know what's the NEP for Tampa Bay. You know, it hasn't been determined, and we have some very specific research questions we'd like to ask as part of our study. You know, what's the sort of long-term average, Bay-wide average? How does the NEP, you know, it's a local, can be determined locally. How does it vary from region to region, say from Old Tampa Bay to Hillsborough Bay? How does it vary with depth? How has it varied since monitoring began, which 1976, we've got this incredible record. Can we see how any NEP has changed? How does it vary seasonally? And we're also interested in just oxygen itself because it's so important variable. And you know, what determines the oxygen level? You know, is exchange with the atmosphere. There's transport by currents. There's NEP itself, which is going to be producing oxygen. And then what's driving the spatial and temporal variations in NEP? So our overall approach is to use this great monitoring data set to create an oxygen budget for Tampa Bay. And from that oxygen budget, we can kind of back out what the NEP is. But first, we have to know what the water transports are, because we think that currents and mixing that are carrying oxygen around can be important. Well, it turns out you can get those, and this is an old technique from the constructing a water and salt budget. So I won't go into the details of that. It's pretty standard approach in estuarine modeling and biogeochemistry. But what we've done is broken up Tampa Bay into 4 regions, and you know, Old Tampa Bay, Hillsborough Bay, Middle Tampa Bay, and Lower Tampa Bay. And we've sort of considered those. We've averaged all the data into those regions. And then we split it vertically into 2 levels with the interface at 4 meters, which is what physical oceanographers tell us generally is the depth at which the lateral circulation changes direction. And then from the salt and water balance equation, so we're using the salinity data. We're using freshwater inputs from Ray Pribble, who's I'm pleased to see he's on the line, and that helps us do the water budget. And then we're able to estimate some of these terms that you're seeing in these 2 boxes in the lower right. What's the surface lateral flow? What's the deep lateral flow? What's the vertical advection, the upwelling or downwelling? And then we also include a 2-way diffusive exchange. That's the K variable there. So that comes out of our water budget and analysis. And if you go to the next slide, Maya, you can see the results of that. Well, hang on, I guess I'm not going to do that yet. First, I'll give you those results in a second. And now I'll tell you, once we get those transports, we can make an oxygen budget. So this is the only equation I'll show here. And I'm giving an example for, it could either be Old Tampa Bay or Hillsborough Bay, which only exchanges with one other system, and that's Middle Tampa Bay. And the terms that we're considering on the left-hand side of the equation is how the oxygen is changing over time. Then in the purple, that's the upwelling of oxygen from below. The blue there is the transport of oxygen from the surface southward into middle Tampa Bay. The green is the exchange of oxygen between the deep layer and the surface layer by mixing. The yellow is the exchange with the atmosphere. And then finally, the blue is the oxygen that comes in the freshwater inputs. And we've assumed equilibrium with the atmosphere. So from our water quality monitoring data and the SALT budget, we know all of those terms except for the NEP. And so we calculate the NEP by difference. That's the basic approach of the method, and it's been around for quite a while, but hasn't been used on Tampa Bay. Here's the result just from the water budget, and I don't really have the time to go through this in a lot of detail, but what you see in the blue are the surface flows, which are all seaward, and in the orange, the deep flows, which are all landward. So it kind of conforms to our expectation of an estuarine sort of overturning circulation with deep salty water coming in from the ocean and fresher water leaving at the surface. And then some of the dots and the cross arrows show the vertical transports and the mixing. And there's actually quite a lot of mixing. You see those numbers are quite high for those cross arrows. We can calculate the residence time of water coming in from the Gulf from this budget, and what we get is about 30 days. So basically the whole system is kind of refreshed with salt water from the ocean every 30 days. And this it's called a residence time. It's been estimated by others. Our estimate tends to be at the low end of these previous estimates, which maybe means our advection is at the high end. Our currents are at the high end of previous studies. You can go to the next slide. So I'll just give you the bottom line for, we did this every month in every one of these boxes from 1976 to 2020. And I'm giving you the overall average for net ecosystem production here for the whole system over this whole time. And it's minus 3.6 moles of oxygen per meter squared per year. It's negative. That means it's net heterotrophic. We can compare that with Maria's statistical model, which I showed you earlier from that curve with all the other estuaries on it. And her model gives a best estimate of minus 4.4 with a fairly large error, about 50%. And so it kind of conforms to what we would expect from the inputs that we know that are coming into Tampa Bay from rivers and from wetlands to some extent. You can go to the next slide. This shows how the NEP varies from region to region, and the different, you have a color scheme there. And the gray is the average for the whole system. So that's the number I've given you. And you can see that Old Tampa Bay is the most heterotrophic, and the least heterotrophic is Hillsborough Bay over the long term. Next slide. We can answer our second question, how does NEP vary with depth? It's always negative in the deeper layer. It's kind of expected. There's less light there, less photosynthesis generally. Surface layers vary. Hillsborough Bay is very autotrophic. You can see that positive green bar pointing upward, and Old Tampa Bay is actually quite heterotrophic at the surface. Next slide. To answer our next research question, how has NEP varied since monitoring began in 1976? And this is where we see some really interesting trends from the mid 70s to the early 80s. We see basically four phases. That first phase is 1976 to 1982. The system is pretty much net autotrophic. This is different from the long-term average and different from how it is now. And then for about 10 years, it goes into a period, a little less than 10 years to 1990. It's mostly and fairly strongly net heterotrophic. Then there's another 10-year period where it's still heterotrophic, but it's weakly so. And then it's been moderately to strongly heterotrophic since then, and fairly stable over the past 20 years or so. Next slide. How does NEP vary with the seasons? Well, it looks like the top graph there is the surface layer average, long-term average annual cycle, and the bottom is the deep layer annual cycle in the 4 different regions. And generally, we see the rates peaking in the summer, getting most positive in the surface layer in the summer and most negative at depth. And this is what in the open ocean we call a biological pump that produces organic matter in surface waters, exports it to deep waters where that organic matter gets consumed. And that biological pump seems to be quite active in Hillsborough Bay, and in all of the systems, it tends to be strongest during the summer. Next slide. And now, what terms are important in the oxygen budget? We don't not only get the NEP, but we get all these lateral transfers and mixing and gas exchange and the variation with time. Turns out in the surface layer, the NEP, the mixing and gas exchange are all important. In the deep layer, it's just NEP and mixing. Both layers combined, its NEP pretty much balances the exchange. So the system is consuming oxygen, right? Is a net consumer of oxygen at minus 3.6 moles per meter squared per year. And that oxygen is pretty much exclusively coming in from the atmosphere. That's what it's telling you. Remarkably, this was a big surprise to us and a little bit disappointing because we spent a lot of time with the box model trying to get these lateral fluxes right. The advection, the lateral advection, and even the vertical advection is just not that important. And that's not to say it's not important in Tampa Bay at all. It's just not important on these time scales and space scales, which are fairly large and fairly long. Of course, tides coming in back and forth will affect oxygen at any point quite a lot. Next slide. Now, what's driving the spatial and temporal variations in NEP? This is really like the most interesting and important part, and turns out to be the hardest part. And we've been struggling with this. There's a lot of other monitoring data besides, oxygen in the bay, and so we've been looking at the chlorophyll data. I've put up these red lines to indicate those 4 phases that I showed before. So, what we're seeing for that first period in the upper left-hand panel is that when chlorophyll levels were quite high, and of course that's when the nitrogen and phosphorus inputs to the estuary were high, and we do have some of that information as well. That stimulated a lot of algal blooms, and that made the system very autotrophic. So that's not too much of a surprise. Chlorophyll levels have progressively come down. I'm showing all these other curves. I don't have a whole lot to say about them in terms of what they mean for NEP. We're doing a lot of statistics right now, trying to relate these water quality data to the NEP to really understand controls. Nothing has really popped out dramatically yet, but we're still working on it. Next slide. So to summarize, we developed an oxygen budget based on monitoring data for Tampa Bay in 4 regions and 2 layers with monthly resolution over this about 45-year period. Tampa Bay is on average, and for the whole system, net heterotrophic. That means it's a consumer of organic matter, organic carbon, consumer of oxygen, producer of CO2. Tampa Bay has shifted from being net autotrophic in the from the mid 70s to the mid 80s to net heterotrophy in the mid 80s, and it's been that way since then. Subsurface waters are net heterotrophic, and surface waters are variable in their metabolic status. The magnitude of NEP rates is highest in the summer, and vertical mixing and gas exchange are key terms in the oxygen budget at the timescales that we looked at. Advection, surprisingly, is not important. So that's it. I'm presenting this to you all, and I worked closely with Marcus on another project, and I've been telling him about it, and he encouraged me to present, and I'm really, really thrilled to do that. I'm doing so because you all know the system very well and in more intimately, or at least in very different ways than I know it. So I'd be most grateful for any thoughts you have about this analysis and what might be driving some of these variations. Thank
There's
you.
a question in the chat. Is that you, Mike Wessel?
Yes.
You want to ask it?
Yeah, I was just curious in the
A little louder.
In the seasonal plots. Can you hear me?
Yes, thank you.
In the seasonal plots that you showed for the NEP, you had the OTB line was pretty flat and near zero seasonally relative to the other bays. And I'm just wondering if you had any thoughts on that, the seasonal, not, yeah.
Yeah, if you can keep going back there. Yeah, I'm puzzled about this, and I wonder if this is just a bathymetric issue. I'm wondering if Old Tampa Bay is just shallower than the other systems, and there's not much there. And these rates are per unit area, so the deeper it is, that I noticed this too, but we haven't looked at it. I'm wondering if it might be just a depth issue. Does anybody know, is Old Tampa Bay shallower than the rest of, I mean, this is something we could easily find out ourselves.
It is, yeah. And it has a longer residence time relative to the other bays for the most part. But it's even lower than it's closer to zero than the surface layer.
Right. But again, it might be because maybe it's just a thin little layer there. So if we look at the rates on a per volume basis, then maybe it could be more comparable in terms of addressing, why, if there are real differences from one place to another.
Mm-hmm. Interesting. Thanks.
Sure.
Are there any additional questions?
So I'll jump in just asking Ray, what do you feel are the next steps where this could be used to manage long-term, primary production within the estuary? What would be your suggestions for that?
For like the management implications of it?
Yeah.
Yeah, I mean, if like this is relevant, if there are issues, I would say related to hypoxia that are of concern or acidification, then understanding NEP would be essential to that. So if you wanted to alleviate either of those, then looking at particular regions where the issue of hypoxia or acidification are most problematic, you would want to look at the NEP in those areas and think about ways to drive down rates. And the choices generally come down to, in most cases, regulating the inputs. And in this case, I think the relevant inputs, as Maria's analysis would show, would be the inorganic nitrogen, which would and the organic carbon inputs.
Thanks.
Well, thanks very much. I appreciate your time. If you have any additional thoughts and want to email me about it or call me, I'd be most grateful. Thanks again.
Thank you. All right, our last presentation today is the ecological benefits of wastewater treatment discharge, direct discharge. Chuck Weber and Sid Flannery.
Good morning, Chuck Weber, Tampa Water Department Director. Thank you for adding us to the agenda on short notice. We really appreciate it. A couple of years ago, almost, the legislation approved Senate Bill 64, and that is requiring Tampa to eliminate our discharge from the Howard F. Kern Advanced Wastewater Treatment Plant to Hillsborough Bay by 2032. Now, that law allows for continued discharge if there is an ecological benefit. DEP was asked at a Tampa City Council meeting earlier this year if Tampa could continue to discharge as an environmental benefit to the bay, and DEP did not give a yes or no answer. And so in conversations about our Pure project, this is coming up. And so we thought that it would be best to try to get a determination from DEP so that we can figure out whether or not this is something that's feasible for compliance with Senate Bill 64. So in following up with DEP to figure out how do we get a determination, they indicated that we should send a written request along with the case for an ecological benefit and any supporting documentation we had. Now, recognizing that there's various viewpoints on the benefits of fresh water from the discharge versus the additional nutrient loading, we wanted to make sure that we asked for the determination in a neutral manner and to get DEP's determination in a way in which we weren't asking a biased question. So along those lines, we asked the stakeholder group that we were working with on the Pure project how we could make that case to DEP for the ecological benefit. Flannery has developed a document that makes a case for that, and the stakeholder group has expressed support for that document. Sid's statements do not necessarily reflect the city's perspective, but they do present a case for an ecological benefit. And so it is the city's intent to ask DEP's determination of an ecological benefit in an unbiased and neutral manner using this as supporting documentation. Now, the city is interested in the tax feedback and comments on this case for an ecological benefit. And with that, I'll turn it over to Sid to present the case.
Well, hello, my name is Sid Flannery. I know many of you, but for those that I don't know, I retired 8 years ago from the Southwest Florida Water Management District, where I worked for nearly 30 years on ecological relationships of freshwater inflows to estuarine rivers. I am the author of a short 9-page report that has the title shown on the screen. As Chuck mentioned, I've been participating in a citizen stakeholders group the city has facilitated concerning the Reclaimed Water initiatives. As part of that process, I prepared a report for the city's consideration, which they have reviewed and intend to send to FDEP. I must say, when I wrote it, I didn't realize it was such a big deal. However, it is still draft, and I may make some revisions or additions to it. So any feedback or comment from the Technical Advisory Committee is welcome. It's been great interacting with the city on this topic, and I appreciate their attention to this issue. But please recognize the views I'll be expressing today are my own, and if I say something in a water management context, it may not reflect the city's position. I know Chuck Weber has some strong opinions about estuarine copepods, so I don't want to misrepresent him. Just kidding. Next slide, please. The proposal for an ecological benefits designation by FDP is a response to legislation that was passed in 2021, often referred to as Senate Bill 64. As stated in the blue text up at the top of the page, I think an ecological benefits designation for the city's discharge of their advanced wastewater treatment plant would provide better protection of the Tampa Bay ecosystem and more effective management of the city of Tampa's water resources. As the bottom bullet says, the legislation requires utilities to eliminate non-beneficial surface water discharges as effluent, reclaimed water, or reuse water, and they must identify the average gallons per day to be eliminated and the average gallons per day that will continue to discharge to surface water and the level in which treatment will receive. As Chuck mentioned, it's my understanding that to comply with this legislation, the city must eliminate 50 million gallons of water per day of their discharge at their advanced wastewater treatment plant by the year 2032. That plant, known as the Howard F. Curran Advanced Wastewater Treatment Plant, is located on Seddon Channel about 1.5 miles south of the mouth of the Hillsborough River. Next slide, please. In this simple application, I believe this bill is not a good fit for the city of Tampa because they draw most of their water supply from the Hillsborough River, which they've been using for water supply for over 100 years. The river is impounded about 10 miles upstream of the river mouth, and flow records at the dam go back to 1938. Prior to the 1970s, there was almost always flow over the dam, but as water use from the reservoir increased, in the 1970s, there began to be periods of no flow when water levels in the reservoir went below the dam spillway. Next slide, please. This slide shows the number of no flows at the dam per year for the period 1995 to 2021, the number of no flow days. When there is flow over the dam, the city can meet their water supply needs from the river. But when there is no flow at the dam, they rely on inflows into and water storage in the reservoir. The average no flow days for this period is about 150 days per year, but notice there is very high variation between years, with over 300 no flow days in the year 2000 to less than 50 days some other years. So as part of the stakeholders process, the question came up, what are you going to do with 50 million gallons of water per day of reclaimed water in wet years? For example, in 2014 and 2015, there were over 300 days each year when there was flow over the dam. The city has identified various uses for this reclaimed water, possible uses for this reclaimed water, such as supplementing potable water supplies or providing minimum flows to the lower Hillsborough River. But the needs for those reclaimed water uses will vary tremendously from year to year. Keep in mind, the water treatment requirements for these different types of reclaimed water uses can be quite rigorous and expensive. Similarly, there are concerns about the water treatment processes that would be needed to make the water safe for various storage options, such as aquifer storage and recovery. As a result, many of us believe the city needs much greater flexibility in how much reclaimed water they would have to deal with on a seasonal and yearly basis. I suppose the legislature meant well, but the simple requirement of having to treat and reroute an average of 50 MGD of reclaimed water is not a good fit for this type of hydrologic system. As I will discuss in the next few minutes, I believe an ecological benefits designation for the city of Tampa as a wastewater treatment discharges as Tampa Bay is technically valid for environmental reasons. And on the water resources side of the coin, if such a determination were made, it would give the city much greater flexibility in how to deal with their reclaimed water options. But now let's talk about freshwater inflows to Tampa Bay. Next slide, please. The Tampa Bypass Canal lies east of the Hillsborough River and was constructed in the channels of 6 Mile Creek and the Palm River between 1966 and 1981. Construction of the bypass canal breached the top of the Florida Aquifer, and the canal now discharges flow of groundwater origin plus storm events. For sake of time, I don't want to go in detail on this slide, but do point out that since the 1980s, the city of Tampa has augmented the reservoir with pumpage from the Harney Canal, which connects the bypass canal to the reservoir. Since 2002, Tampa Bay Water has made withdrawals from both the middle and lower pools of the bypass canal, and during high flows in the Hillsborough River, they can divert water through the Harney Canal to the bypass canal and withdraw it from there. Next slide, please. This slide shows average monthly withdrawals from the combined Hillsborough River Tampa Bypass Canal for 1985 to 2019. The blue dots are withdrawals by the city of Tampa. The red dots that start in 2002 are the total withdrawals, which include Tampa Bay Water's withdrawals. Note that since 2002, there has been a large increase in total water supply draws from the combined reservoir canal system. Next, please. This slide lists average water supply withdrawals from the combined river canal system for 6 years from 2013 to 2018, which I could get records for. Note the city of Tampa's withdrawals average 74 million gallons per day. Tampa Bay Water's withdrawals average 50 million gallons per day, and the total combined withdrawals average 124 MGD. By contrast, the city's discharge at their advanced wastewater treatment plant averaged 56 MGD. So discharges at the wastewater treatment plant are not new fresh water to Tampa Bay, but instead just replace a portion of the water that is removed for water supply. So now let's talk about the ecology of Tampa Bay. Next slide, please. The city's wastewater treatment plant discharges on Seddon Channel, which is in Hillsborough Bay in the northeast corner of Tampa Bay. Both historically and currently, Hillsborough Bay receives the greatest freshwater inflow of the 4 main segments of Tampa Bay, in large part due to flows from the Alafia and Hillsborough rivers. Next slide. This slide is from the Tampa Bay Estuary Program and shows box and whisker plots for salinity in Hillsborough Bay and Lower Tampa Bay. Notice that salinity is somewhat higher and less variable in Lower Tampa Bay due to its close connection to the Gulf of Mexico. The statement above the graph tells a story. I closely paraphrase this language from the Estuaries Program's website, and it reads, salinity generally ranges from 25 to 38 parts per thousand in Lower Tampa Bay, while Hillsborough Bay has a salinity range of 15 to 30 parts per thousand. Keep in mind that Tampa Bay is an estuary, which by definition is a coastal water body which receives freshwater inflow. As a result, estuaries have lower and more variable salinity than marine waters, which is important to maintaining their ecology and biological productivity. If freshwater inflows are dramatically reduced and salinity goes too high, marine fauna can invade the estuary in greater abundance and affect the system's ecology and productivity. Similarly, oysters thrive in medium and fluctuating salinities, and high stable salinities make them susceptible to parasites and predators. Hillsborough Bay comprises one of the main open waters of Tampa Bay, with salinity values that are frequently less than 25 parts per thousand. And freshwater inflows are important to the overall ecology of this important segment of the bay. Next. One of the most important functions of estuaries is their role in fisheries production. Sport and commercial fisheries are multi-billion-dollar industries in Florida, and a majority of species comprising Florida's sport and commercial fisheries are estuarine dependent, meaning they rely on estuaries at some point in their life cycle, which includes species such as snook, blue crab, tarpon, red drum, and pink shrimp. This graphic shows the life cycle of snook, which spawn near the mouths of rivers or in the open waters of the bay and migrate into tidal river habitats as juveniles, then migrate seaward as they mature. This is the well-known nursery function of estuaries you've often heard about. Next. Here's some real data in this regard from the Little Manatee River produced by Dr. Ernst Peebles of the University of South Florida College of Marine Science. What is plotted on the y-axis is mean salinity at capture for the life stages of 5 species of fish. The labels on the bottom of the graph are life stages, with flexion stages being larval stages and juveniles on the right. They increase with age towards the right. The larvae are found near the mouths of the river and in the bay in higher salinity waters, but the juveniles migrate into low salinity waters. Without a doubt, management of these low salinity zones in tidal rivers is very important, but what goes on in the higher salinity zones in the bay is important as well. Next slide, please. This slide is from other related work by Dr. Peebles has done, in which USF did plankton net surveys in Hillsborough Bay and Middle Tampa Bay during 1993, with sampling stations shown in the map on the right. They were looking at the distribution of eggs of the bay anchovy, a photo of which is shown on the slide. The bay anchovy is one of the most abundant fishes in Tampa Bay and is important to overall estuarine productivity as it is preyed on by many sport fishes. The photo below that are copepods, which are small microscopic crustaceans that are important prey items for the anchovies that feed on them. Next slide, please. This graphic shows the distribution of copepods and eggs of the bay anchovy on 3 sampling trips at the end of the wet season in 1993. The copepods are on the top, while the bay anchovy eggs are on the bottom, with the darker shading indicating higher numbers. In the wet season, the highest numbers for both the copepods and anchovy eggs are in or toward Middle Tampa Bay. Next slide, please. And what I did here is I pulled the middle graph from the previous slide to this slide to illustrate the main sources of freshwater inflow during this project, which are shown by the dots in the top graph. Yellow represents the Hillsborough River and the Tampa Bypass Canal in the north. Blue is for the city's advanced wastewater treatment plant, and yellow again for the Alafia and Little Manatee Rivers to the south. What is shown on the table on the left are the average flows for these 3 water sources for 10 days prior to the wet season sampling in 1993. The low value for the Hillsborough River is very unusual, for this time of year, as flows did not resume over the dam until mid-September in 1993, which is when it increased rapidly. The 22 million gallons per day listed for the Hillsborough River is from Sulphur Springs, which flows to the river about 2 miles below the dam. Note that the flows from the Advanced Wastewater Treatment Plant and the Bypass Canal are at 42 and 124 MGD respectively. Also see the high flows for the Alafai and Little Manatee rivers. Next slide, please. This slide is for the sampling at the end of the dry season in this 1993 study. As you can see, the peak locations for both the copepods and the bay anchovy eggs have shifted into Hillsborough Bay, which I said earlier is a very important ecological zone of Tampa Bay. As freshwater flows decline, the copepods, which are food for the anchovies, shift toward the sources of freshwater inflow. And the statement at the bottom of this slide is taken directly from Dr. Peebles' paper. Calanoids are aggregated near sites of stable freshwater discharge in a dry season. Calanoids are the type of copepods that they were measuring. Next slide, please. So again, let's look at the flow numbers for the 5 freshwater sources at the end of the sampling of the dry season in 1993. You can see that Hillsborough River is again low, as this represents flow only from Sulphur Springs. But note that the flows from the city's wastewater treatment plant and the bypass canal are about 44 and 48 MGD. Flows from the Alafai Little Manatee rivers are also much reduced from their wet season values. Next slide, please. This slide shows the same graphic on the right and the same 1993 dry season flow numbers in the top table on the left. Below that are the flow numbers for the same 10-day period in the spring of 2019. The numbers are relatively similar between the 2 years, but there's much less flow coming from the Tampa Bypass Canal in 2019 due to the increased water supply withdrawals from that system. In fact, the 7 MGD value is kind of misleading, as there were flows for only a few days at that location in the spring of May of 2019. But note the asterisk. I was able to obtain flow records for the Tampa Bypass Canal for a 10-year period from 2010 to 2019. For 61% of the days during that period, there was 0 flow from the Tampa Bypass Canal to Tampa Bay, which is due to the increased water supplies from that canal. I also was able to obtain records from the USGS for a period of 1980 to 1989. The median flow for that period was 41 MGD, as opposed to 61% of days of no flow in the more recent period. Now, one could accurately say that flows in the top table for 1993 in the earlier period were elevated due to groundwater discharge to the canal, but 0 flow for 61% of the days in the recent period is clearly not natural. It would not reflect the dry season flow characteristics of the old 6 Mile Creek that was excavated to form the canal. What's important is that the duration of these no-flow days on the bypass canal could be very prolonged. For example, there were 275 no-flow days during the year 2017. But here is the key point. These no-flow days on the bypass canal largely coincide when there is no flow at the Hillsborough River Dam, when flows are limited to flows from Sulphur Springs and very small minimum flow releases from the reservoir, which have averaged about 3 MGD in recent years. Again, no flow days at the dam occur in about 150 days a year on average, but can be over 250 days in some years. During these prolonged times of no flow from both the bypass canal and the river reservoir, the city's advanced wastewater treatment plant provides the majority of freshwater flow to Upper Hillsborough Bay. As the graphic on the right indicates, Hillsborough Bay is ecologically a very important zone of Tampa Bay, and its productivity is related to freshwater inflows. We don't fish for bay anchovies, but it and other forage fish species with similar life histories are important prey items for fishes of sport and commercial importance. On page 7 of my report, there are references to several studies from Florida, other states, and other countries that show that freshwater inflows often have a positive relationship on fisheries production in estuaries, including red drum and Tampa Bay. Freshwater inflows are particularly important in the springtime when many fish species are spawning. In peninsular Florida, freshwater inflows are at their lowest in the spring, and that is when discharge from the city's wastewater treatment plant typically comprises the highest proportion of total freshwater inflow to Upper Hillsborough Bay. Next slide, please. So in sum, based on my review of the hydrology and ecology of Tampa Bay, particularly Hillsborough Bay, I have no doubt that discharges from the city's advanced wastewater treatment plant are having a beneficial effect on Tampa Bay, especially in recent years as water supply withdrawals have increased from areas rivers. Obviously, we have potentially some complicating factors, but it is having some beneficial effects. But here's important. I believe that some of this AWT discharge can be removed without causing adverse environmental impacts. However, this needs to be assessed on a case-by-cases as reclaimed water projects are proposed. As my report says, this is analogous to the minimum flows program administered by the state's 5 water management districts, which, based on copious data, accepts that freshwater flows have a beneficial ecological effect, but some water can be removed without causing significant environmental harm. I think that general principle could apply here. On the water resources side of the issue, the City of Tampa could incrementally evaluate reclaimed water projects over time, considering their needs, infrastructure and treatment costs, and public interest. As these items are being addressed, they can also evaluate the effects of diverting the corresponding quantity of AWT discharge away from the bay using established analytical tools that are described in my report. I believe the city conceptually agrees with this approach. The important thing is that this is done on a case-by-case basis over time. This is entirely different than mandating the city divert 50 million gallons a day of wastewater discharge away from the bay within 10 years and trying to force fit it somewhere. Maybe the legislature, with its variety of influences, meant well, but I believe that requiring the city to divert 50 MGD of reclaimed water away from Tampa Bay within 10 years is problematic, considering the hydrologic characteristics of their primary water supply source, the Hillsborough River, that the need for reclaimed water can vary greatly between wet and dry years, and the ecological benefits of the existing discharge to Tampa Bay. So with that perspective, let's go to my closing slide. I want to stress that a designation of ecological benefits to the bay from the city's wastewater treatment discharge is intended solely as it applies to implementation of Senate Bill 64 by the Florida Department of Environmental Protection. It's not something to be highlighted at, statewide conferences or trumpeted from the rooftops. The important part of this ecological designation would be as it applies to Senate Bill 64. So I want to emphasize these points. Discharges from the City of Tampa's AWT plant provide valuable ecological benefits to Tampa Bay, which have increased in importance as greater water supply withdrawals have been taken from the Hillsborough River and Tampa Bypass Canal. I really want to emphasize the second bullet strongly. A determination of ecological benefits by the DEP would not preclude the pursuit of reclaimed water projects by the City of Tampa using highly treated AWT discharge. Let's stop there. As previously discussed, the evaluation of reclaimed water projects can be done on a case-by-cases as they are proposed by the city over time. In all likelihood, I think some of this discharge can be removed from the bay, but it should be supported by its effects on the bay using existing analytical tools. In the second part of that same bullet, I think that the designation of ecological benefits would not preclude the diversion and use of the discharge for habitat restoration projects. I know there's some concern about that from environmental professionals in the region. And similarly, this ecological designation as it applies to Senate Bill 64 would not preclude the use of the reclaimed water for that perspective. Also, I think the third bullet is very important with regard to the NEP Tampa Estuary Program. The termination of ecological benefits would not preclude the pursuit of additional nutrient load reduction strategies if determined necessary by the Tampa Estuary Program. In addition to diverting the AWT water for suitable reclaimed water projects, there are other processes and measures that could be applied to reduce the City of Tampa's nutrient load to the bay if that were determined to be necessary. So overall, I think the determination of ecological benefits in this case is well justified and represents a comprehensive and balanced approach that provides much better for the natural resources of Tampa Bay and gives the city of Tampa much needed flexibility to pursue reclaimed water projects that are in the best public interest. Finally, my report had a number of graphics that showed trends and important ecological variables in the bay that are regularly reported by the estuary program, which generally show promising trends. For the sake of time, however, I'm not showing those graphics today, but can discuss those results in the context of a beneficial ecological designation for the City of Tampa's wastewater discharge with anyone whenever you like. Hey, thanks very much for your time. I'd be happy to take any questions or comments.
Okay.
We have 2 comments in the chat. Dave, do you want to read, make your statement?
Yeah, sure. And hey, Sid, thanks for bringing up this topic. It's certainly not in my geographic area, but what I kind of wondered was there seems like water that would be potentially diverted away from a direct discharge towards reclaim, for example, which is what the city of Sarasota does, which is what Sarasota County is doing. They're planning on being AWT, Sarasota County, like the city of Sarasota, where they don't have a direct discharge, even though they're AWT. And wouldn't that actually kind of relieve some of the pressure of that amount of water removed from the Tampa Bypass Canal that's used for irrigating water, which is like maybe half of the water used anyway? So, I mean, couldn't there be a plus of taking reclaimed water, further reducing nutrient loads by applying it as reclaimed on the watershed, which is what we're doing down here, and also, allowing more water to come down the Tampa Bypass Canal, because so much of our water is just used for irrigating our lawns. So it seems like there's a potential win-win. I don't know. I'm just bringing that up.
Let me call my planner friends on that one. No, I'm just kidding. It's interesting, Dave. That subject gets brought up quite a bit. The citizens are really encouraging the city of Tampa to provide more reclaimed water for lawn irrigation. But Chuck could speak to this. They've already got a big system. There's lots of financial concerns there, that kind of thing. I think the main thing is your point's well taken. Potentially that could reduce water use. That's correct. But it would alleviate people from using potable water to water lawns. So that's really in the planning side of this. I think that the factor that's related to this is the city of Tampa could put various reclaimed water options on the table and look at pluses and minuses of these, the need, the cost, and that kind of, and they are currently looking at that sort of thing. And in that regard,
Sid, I'm sorry to interrupt you, but I do want to address that directly. That is one of the options that we are considering under the PURE project. Expanding that purple pipe system that we have is a huge challenge for the city of Tampa because we're urbanized, and trying to get the pipe system through the city to the places where reclaimed water is used the most or could be used the most is an economic challenge. So we are looking at different ways of, instead of, piping it everywhere, which is super expensive, are there areas where there's a benefit if you just focus on one area of high use? Could you get a pipe out to there cheaper? So that is one of the many ways we're looking at trying to take the water and put it back into the watershed and have it come back down through the river or the bypass canal, or even just through irrigation.
And that's basically what the city of Sarasota does. They're not putting reclaimed water into the older neighborhoods. They're sending it out towards Lakewood Ranch. So they're looking for the new development. I used to live in New Tampa. There's plenty of places out there would love reclaimed water. But, city of Sarasota isn't putting it to all the older places in the city of Sarasota. It's putting it towards rapidly growing new development where they need reclaimed water. So maybe there's some parallels.
Even just selling the water to another user in the watershed who can offset the demands on the river and the aquifer would be another way to accomplish that same thing. And of course, selling the reclaimed water to, say, Hillsborough County, they have a better opportunity to put in purple pipe systems at a cheaper cost in the area that they have. So that would be one way to approach that, yeah.
Again, Dave, I want to emphasize that ecological benefit designation does not preclude the pursuit of reclaimed water options. And we feel we give the city more time and flexibility to pursue options that make the most sense from a number of perspectives.
I mean, it doesn't preclude it, but if that was what their plan was to address Senate Bill 64 to reduce the direct discharge, if it was stated explicitly that it was to develop a robust reclaim system or to sell the effluent to another utility, I mean, that's a little bit stronger than not being precluded, right?
Well, I suppose so. It's just wording. Such options could be pursued, could be investigated. Yes. Mm-hmm.
We have Rich Brown, who's requested to make a comment.
Yes, hi, thank you very much. I am Rich Brown. I represent the Friends of the Hillsborough River. Today, I'm also speaking on behalf of the Tampa Bay group of the Sierra Club and the League of Women Voters of Hillsborough County. We're all part of the stakeholders group formed by the City of Tampa Water Department. The following statement represents the position of all three organizations. We have each reviewed today's report as prepared by Mr. Flannery. We strongly support the positions raised in it. The discharge of reclaimed water currently to the bay seems to have significant positive ecological benefits, especially during the dry season. Several of the other presentations today would seem to support that concept. The ecological benefit designation would not preclude any future development of uses of reclaimed water, and in fact, it would give time for careful planning and evaluation of those uses and the standards required to do them carefully. We believe an ecological benefits designation is truly a win-win for the whole region. Thank you. We look forward to continued collaboration with all of you. That's it.
Thank you. Any additional discussion on this item? All right, again, if encourage you to submit any comments through the chat function, and Maya's compiling everything. So
I've got my hand raised, Kelly.
oh, sorry, I didn't see it. It's like this big, Ed.
No worries. So no doubt this is a complex resource management question, and we've been in discussion with Sid and the city on it for sure. The last 3 bullet points on this slide are things that, from the estuary program's perspective, are points that we strongly urge the city to consider moving forward. I don't want this to become an all or nothing sort of question or reaction to how a DEP might develop its determination for Tampa Bay. Going back through the history and management of Tampa Bay and how we got the seagrasses back, and building the collaborations and partnerships going all the way back to the 1990s, there was commitments from all the municipalities within the region to reduce nutrient loads to Tampa Bay by the tune of about 17 tons per year on an annual basis. So about 85 tons over 5-year assessment periods. And to a certain extent, we've made great progress and we've done a good job of reducing nitrogen loads to the bay to the point where we've regained seagrasses to a peak condition in 2016. But over that 35 plus year history, we're now in a much different place. From 2016 on, we're seeing signs of seagrass losses and other signs of eutrophication that should create some pause and concern for our resource management community, that we can't maintain status quo, that we need to continue to be vigilant in terms of how we manage nutrient loadings to Tampa Bay. And quite frankly, the discharge from the wastewater treatment plant is a significant load to the Hillsborough Bay segment. That in and of itself is something we are very committed to keep within our comprehensive management plan, and trying to encourage partners to look at novel ways to continue to reduce nutrient loads from no matter the source into the Tampa Bay estuary. So as I started, I don't want to view this sort of progression events to be an all or nothing thing. From the estuary program's perspective, we don't view it as a very realistic thing to remove all of the discharge from the Howard F. Curran plant from Hillsborough Bay. But there are gray areas, and we don't think that the existing load and the existing growth within the region is going to allow us to maintain the status quo. So there's got to be some sort of compromise of how we move forward in dealing with both the freshwater inputs to this bay segment as well as the nutrient inputs. And I want to make very clear that that over the last 5-year assessment period, and we'll be delivering this report to the Department of Environmental Protection, we've lost a significant amount of seagrass resources to the tune of about 6,000 acres bay-wide, the majority of which have been in the upper bay segments, both Hillsborough Bay and Old Tampa Bay. In 2020, the seagrasses in Hillsborough Bay were 837 acres. That represented a 58% loss from the peak conditions in 2016. So we're by no means in a pristine condition in terms of the ecology of the upper portions of Tampa Bay. So we got to remain vigilant, is my point, that we can't maintain the status quo if we're going to continue and expect to grow within the region. We're going to have to compensate for additional wastewater treatment capacity by our municipal governments. And we need to manage water resources within the region a little bit more comprehensively than we have in the past. So, the point of view from the estuary program, I think are very clearly highlighted in this last slide by Sid. And I just don't want this be a moment in time where we can't make the generational investments to do the right thing and make sure that we have a sustainable bay moving forward. Because I think ultimately, and then, we will get what we don't invest in or what we do invest in the future. And that's something we have to weigh as a community. Those were the main points I wanted to provide. I don't necessarily disagree with any of the ecological benefit points that Sid presented this morning. It's just that we're in a much different place in terms of the bay's ecology and the recovery. From 2016, 2018, and 2020, we've had 2 straight seagrass assessments where we're not on a positive trajectory in terms of seagrass resources. And we're expecting in 2022 numbers to once again be in a declining situation in terms of seagrass. We have not experienced that over the long-term history of managing seagrasses in Tampa Bay. There's only been one other period in 1998 where we saw a dip, and then we've seen a positive improvement since that time. From 2016 to now, we're in a much different place, and we're seeing warning signs within the bay that should give us pause for concern of how we manage these resources moving forward. So I'll end there and allow others to provide comment, but I just wanted to raise those points in terms of looking holistically at where we're at in terms of the overall ecology of the bay and where we are in the long-term recovery stages.
Any additional conversation or comments, questions at this time?
I'll just echo, I think everything that Ed said, and, want to emphasize to the city and to the stakeholders that I think that there are these other options that are not precluded, but they're definitely very worthy of pursuit. And I think that it would be important that that's part of a plan, whether it's to eliminate, all 50 MGD of the direct discharge or a portion of it, to be explicit about what the commitment is for the beneficial reuse of that effluent is really important. And I'd encourage us to think about ways that we can deliver this water to the bay in a way where it is, cleaner than what we're treating it to now, and it's delivered in a fashion where the timing delivery is more closely aligned with the natural flows that the bay would see. So that would be, you know, my wish for what to do with this resource.
Okay, thank you, Maya. All right, so we have open discussion, but we have a living shoreline seawall discussion here. Anya?
Yeah, Anya and James, I chatted with you. I tried to see, would one of you like to take control, and if so, who?
Yeah, definitely. Anya's going to take control effectively.
Okay.
Excellent. Shall I do a little introduction?
Yeah, James, actually, will you take control?
Oh, yeah, sure, I can take control. Yeah, whoever has the capability to give me control, you do that, and I will be able to present. We'll be able to present. Oh, brilliant. Thank you. Okay. Fabulous. So, you guys see that?
Yes.
Yes.
Wonderful. Thank you. Well, thank you so much for letting us come today. I'm currently sat in London, but typically sat with Anya in Miami. We're really excited to share an innovation with you today that's come about through an amazing number of technologies that we believe can transform the way that seawalls and the environment come together. As mentioned, we're thinking of this as a living seawall, and what we want to do is empower nature to do its thing using technology. So without further ado, I'd love to hand over to my co-founder, Anya, to take it away, if that's all right.
Sure. So basically, as James mentioned, we're a startup. We're based in Florida, and having a technology and entrepreneurship background, we started thinking about how can we innovate this 100-year-old industry and 100-year-old construction methodology of seawalls. And we came up with a solution that you will see is quite different from what has been done in the past. So right now, seawalls primarily look like this. Obviously, you have them all over Tampa, and it's really kind of like a necessary evil. They are required to protect coastal communities from rising sea levels, flooding, storm surges, but they cause a lot of environmental problems, and they're also expensive and very slow to construct. So right now, the way seawalls are made are primarily with molds, and molds take like 24 hours per panel. They require a lot of labor, and that really brings up the cost of the production of the panels, and also the whole installation of the seawalls is also very expensive and time consuming. And then once you put in that seawall, as you know, obviously it destroys the habitat because marine life cannot attach to a flat panel. It leaches chemicals into the water, which increases toxicity. And also it's not great for wave energy because the wave energy just bounces off the flat panels. So what we're doing looks like, I'm back. Looks like this. So this is a convergence of a few technology, most importantly, 3D printing, also some material science and sensor tech. So instead of using molds, we are creating seawalls with autonomous 3D printers. So the seawalls, first of all, are structural. So they have the exact same PSI, the same strength requirements as conventional seawall panels. They have identical installation methodology, so any contractor can swap the panels that they were using in their plans for our panels. And they have identical materials for starters. So they are concrete, but they have an additive which prevents them from leaching toxins into the water. But because it's 3D printing, it's also radically different. So we make our panels with our robots, which means that with no added cost, we can make the panel have this incredible ecological shape. So as you see, it mimics mangrove roots and artificial reefs, and therefore it hosts multiple biodiversity, multiple organisms, oysters and crustaceans at the bottom of them. There's also caves for fish to hide from predators. And because of all of that, this panel becomes self-mitigating. So you don't have to offset negative impact of the panel, because actually has a positive impact on biodiversity and also some carbon sequestration, which I will talk about.
It's also worth mentioning that the beautiful thing is it's completely modular. So the benefit of this approach through 3D printing is we can not only produce these incredible designs, and the picture you see in the middle here is one of our walls. This is what they actually look like. So it's structural, but it looks like this, and it has those benefits, as you said. But we can also expand that wall vertically. So when needed, we can add additional wall to the top and also create a cap that can be removed and added back on. So think of it a little bit like a very sophisticated Lego. So that is another real benefit of this approach.
Okay, so just two environmental benefits to highlight. One is its function as a reef. So again, with the freedom of design, we created the panel that mimics artificial reefs and mangroves. Mangroves, it has 3-inch caves, which is the ideal from our advisors, our understanding as the ideal depth of sea life to hide from predators. And because of the materials also don't leach chemicals, biodiversity is able to attach to the seawall panels, enhancing the ecosystem and providing bioprotection. And also as a bonus, when obviously that biodiversity is in the area, they're also consuming the toxins in the water. So the quality of water is also not damaged by these seawalls, unlike a conventional seawall panel. And then second benefit is that the seawalls, because of their function as our artificial reef, can also sequester carbon. So through a process that all of you scientists are very familiar with, it's biocalcification. So different organisms like oysters, corals, tube worms, algae, barnacles, when they attach to the seawall, they actually deposit their skeletons into the wall. And the skeletons is what assimilates the carbon. So each one of our panels is about 10 by 10 feet. We can make any size, but on average is 10 by 10 feet, and it sequesters 40 pounds of carbon per year, which is equivalent of a tree. So when you have these very large projects that are miles long, that's a very significant carbon sequestration function. And another bonus is that these skeletons also contribute to the strength and the longevity of the walls, because again, they add structure to the panels. The third and last environmental benefit is that we have built-in sensors. So we have a sensor partner that provides us a sensor, and it's really a revolution in sensor technology because, as you know, and I heard a lot of presentation today about data. In the past, you had to, first of all, collect data manually, but also have different sensors for different parameters. We are able to collect 15 data points with one sensor per seawall project. So as you can see, this is what we're collecting: conductivity, temperature, dissolved oxygen, dissolved solids, ORP, pressure, salinity, saturation, pH. And a lot of these are also indicators for harmful algae bloom, as you know. So it's something that we can track ahead of time. And also do other analytics like on this data, like extreme weather analytics. And because the seawalls communicate with each other, the more seawalls that we have, the more we're able actually to map kind of the ocean and map traction of things like algae or any toxicity in the water as it moves from point A to point B. And again, all of this is live. You don't need like the big, what they call it, the big tower you need in the past to transmit that data. With 5G, it's just automatically uploaded to our software. Okay, and the beauty of this is that all of these benefits are at no added cost. So we are able to match the price of what the contractors were spending to make their own panels to create our panels and still have all of these environmental benefits. And that's because of the time and then the cost efficiencies that we are able to achieve with 3D printing, and with that margin be able to add a lot of these environmental benefits that you could never achieve with a mold. James and I actually, we tried to make these panels with a mold before we started 3D printing, and it's insane. It is impossible to get the details necessary for this to function as a reef in a mold. It's cost prohibitive, time prohibitive, technologically prohibitive. So that's it. And the way we're functioning now is that we actually sell the panels to contractors, local contractors, and they do all the installation and they do all the permitting. But they can capture that time savings in the permitting process and the overall cost of the project by using our panels because they don't need to do any kind of mitigation. And I think that's the gist of our presentation. I try not to bore anybody, but if you have any questions, we're very, very happy to answer.
Yeah, we're obviously really excited about this possibility. So please, please ask any questions because hopefully it's something that you haven't seen before. We believe we're the only company in the world doing it. We're proud to be a Miami company, proud to be a Florida company, and we're really excited to talk to you guys today.
If you haven't met with the Tampa Bay Marine Contractors Association, I would suggest you reach out to them. They have a website and they meet quarterly. So you get them all in the room all at once. And I think that would be a great opportunity for you to share this, with the local contractors who actually do the work here. So
that's a good idea.
Yeah, thanks so much. That's great. We definitely will.
Are there any other comments or questions that anyone has?
I might have missed it. I just had a brief question. Did you discuss the costs and how it's comparable to traditional seawall approaches?
Exactly. So we are matching the price that right now contractors make their own panels primarily using molds. So for example, Miami costs about $20 to $25 per square foot to make their own panels. We can print our panels at $18 and sell the panels to contractors at the same price that they were spending to make their own panels. So there's no added cost to achieve all of these environmental benefits. And for us, the economics are so... Go ahead, James.
Yeah, I was going to say, what's also quite exciting is we're in the process of talking with Derm at the moment about proving the fact that it's a self-mitigating panel. And so the benefit of that is, as it stands today, our panel, it matches the price. But if we get the certification that we expect to get, then it will reduce the permitting time for people, which obviously saves time and money, and also means that you can get protection in the water faster. But also, by doing that, you'll ultimately reduce the overall cost of the project. So the permitting time being reduced and the mitigation being reduced means that the overall project cost is reduced such that the panels become even cheaper.
I had a question if you guys can hear me.
Yes.
David, we can.
One of the things we're seeing down in Sarasota is the traditional concrete seawalls that actually oysters can attach to quite easily are being replaced with vinyl seawalls, so plastic seawalls. And it looks like from early kind of census of these things, it looks like barnacles can attach, and maybe oyster spat, but like oysters themselves don't seem to be able to attach to these. So we're actually looking at working with our local governments to try to find out if we can have additional like permit requirements, which is you can have your plastic seawall because they're going in all over the place. DEP is permitting them. But you have to do something on the outside of it. So just keep in mind that there is a potential market as well as these vinyl seawalls get permitted all over the place. They do not appear to be supporting oysters. And that's a big difference because the traditional flat seawall might not have been ideal for wave energy, but they supported oysters. These guys don't.
Exactly, David. You're right. Concrete is actually a great material when it comes to artificial reefs, as long as it's not leaching chemicals. Non-toxic concrete is fantastic. We are able to do like a thinner version of our panel, which can be attached to an existing seawall, but we really wanted to tie it into a structural product so we can really scale. So it's not an add-on product that people have to spend additional money, but the fundamental seawall also has these ecological benefits. But it's something we can definitely do.
Please email me, dave@sarasotobay.org. We'd love to hear more about it. Thank you.
Thank you, I will.
Thanks, Dave. I've also put my email address in the chat. So John had a question I answered, and CJ Reynolds had a question I answered. So I've answered those in the chat. If anyone else has got any questions, please feel free to ask them or chat them.
All right, thank you. We have a CJ, your hands up.
Yeah, I asked an either or question, James, so you need to, you're like yes to both or yes to one. So thank you for clarification. I'm sure I'll work with Maya and all of y'all and Alana
Great.
to learn more about your process. It's important to our members who are very interested in understanding this from all
So
perspectives,
the
science and business.
yeah, so
Thank you.
sorry, you're right. So the idea is to be able we'll start, and then we will license.
So in phase one, we are producing the panels ourselves and selling them to local contractors who do the installation and do the permitting. In phase two, again, to scale to all the cities that need this technology, we will license the robots, provide materials and the training so the contractors can execute these projects themselves. And again, that's because we're in a rush to get to all the cities that need this technology, in light of the rising sea levels and increasing challenge.
Okay. So we have another hand up, Colleen Weaver.
Hi, Colleen. Hi, Commissioner.
Excellent. How you doing?
You're muted.
You're on mute.
Can I ask a real quick question while they're unmuted? Yeah, I was just curious. Do you have any applications with the autonomous monitoring? Have you had any installations where you're actually collecting data?
Not in Florida. So we've done all this in the lab setting so far in Europe with the strength test, the ecological test, the sensors. The robots arrive in Florida in December. We already have tons and tons of pre-orders. So we're training our team and we start all the installations in December, January. So the first projects now are as of right now in Coral Gables, some private projects, they will have the sensors. But we are open to projects anywhere in Florida.
Thank you.
Colleen, it looks
when I say robots, yes, I mean 3D printers.
You want to
Thanks
try
for the
the
question.
Looks like you're still, now maybe your speakers are turned off. Can you type your question into the chat? I don't know if she can hear me.
Hey, Anya and James, this is Brendan Myers from the U.S. Fish and Wildlife Service. I missed the part where you explained the process that makes the permitting challenging, challenges less challenging and quicker. Could you go over that again, please?
Sure, and I think this is unique to different counties. So I'm not sure exactly what the Tampa Bay requirements are, but for example, Miami-Dade, when you install a conventional flat seawall, it destroys the habitat. Therefore, contractors are required by DERM to offset, to mitigate that environmental damage by creating alternative habitats, which is primarily here down with the riprap, which, like the big boulders. So that adds a lot of permitting time, the back and forth, because then often, by the way, you have to mitigate the mitigation because they add the riprap and then goes too far into the canal. So all the back and forth adds a lot of permitting time. Over 50% of the permitting time is the mitigation. And also the overall cost of the project, obviously, by having to add riprap or additional components to the projects is also very expensive.
Fantastic. That sounds great. I would maybe caution having that as a large selling point, because in several places in Florida, there's 3 different permitting processes that need to happen: county, state, and federal level. And many times it's not the county and state that holds things up. It's unfortunately the federal side, which I am on, that holds things up. So yeah, sounds good. Thank you.
And I think something the commissioner has mentioned is that there may be some permitting, special permits for living seawalls that are not available to conventional seawalls. So something we're also exploring. That would be fantastic, of course. Like capitalizing on any incentives that exist.
Okay. I think we'll have to, I think Colleen is still trying to get her.
Yeah, she put her comment in the chat, which was just to say thank you and to let folks know that Pasco County is planning to implement this technology within their county.
Okay, great.
Yeah, we'll be in touch next week with James, so we're very excited.
Thank you very much. One thing I have, because we do like the permitting on, like mentioned on the county side of, at least on the county side of things. Anything we can do to get them pre-engineered approved makes the permitting a lot easier. So if it's a panel and it's got to meet certain structural requirements and those types of things, if we get all that engineering like done up front, then the permit, then you don't have to like literally have engineering on every single seawall. We're approving a spec. So it's just a thought.
Exactly, Kelly. We would love to work through our process, and that's why we're standardizing the panels so that we can get that approval, like a blanket approval, and not have to go through a process each time.
Yeah. Okay. All right. Last, we have post-hurricane monitoring update, Piney Point October stormwater discharge. I'm not sure who's speaking on that one.
Do you want to, Ed, or you want me to?
I think we were just trying to encourage a general discussion to see where everyone was at in terms of monitoring after Ian's passage. I know some groups have been out there in response to the continued Piney Point releases of stormwater, but we wanted just to gauge the community to see where you're at in terms of ambient monitoring as well. So mainly a free-form discussion on that point. I know there's going to be some groups out, I believe next week, doing some seagrass transect work in middle and lower Tampa Bay.
Ed, I can summarize what I know about our system and farther south.
Yeah.
Sarasota Bay is sort of like the southern part of Sarasota Bay experienced like around 15 inches of rain and hurricane force winds. The northern part experienced like maybe 5 to 10 inches and mostly tropical storm force winds. So the lower part of Sarasota Bay is the area that we're focusing on. We've been going out every week doing field measurements and also sampling offshore, about 2 miles offshore, and then at the inlets in the lower bay. And a couple of things that we're finding is we're seeing salinity stratification. Our estimates are that we've roughly replaced about half the water in Sarasota Bay and salinity stratification in the bay with bottom water hypoxia. So the surface layer might be 0 to 8 parts per thousand. The bottom might be hypoxic, but not everywhere. I want to give a big shout out to Chris Anastasia for helping us out on this. We've been sampling nutrients and everything like that. Bacteria levels for enterococci, about half our sites exceed the criteria, sometimes by a factor of 4. Down in Lemon Bay, they're exceeding the enterococci criteria by more than 100 in various locations. So the lower Peace River, the lower 20 miles at least, has no oxygen in it, top or bottom. So we're seeing basically what we think we're going to see is pretty much all the fish in the lower part of Peace River are going to die and wash down into the harbor. So the harbor's a mess. Lemon Bay is a mess. Really high levels of bacteria. We're trying to get the word out about being careful out there. We've already had volunteers who have died from Vibrio infections. So, it's a mess, but the farther north you get, the less the impact is. But we are seeing a lot of problems. And I just want to give a big shout out to Charlotte County, Brandon Moody, ESA, Emily Keenan, Bob Worth, Chris Anastasia, Christine Angelini at UF for really working together to collect samples during a time where a lot of staff and a lot of people don't even have houses to go back to. So it's been a real challenge, but we are responding, kind of using the same approach that you guys did with Piney Point. We're actually having Miles Medina help us to put together sort of a dashboard the way Marcus did. So we appreciate everything that you guys went through with Piney Point, because we're trying to replicate that for what we did with Ian. But we're complicated by the fact that there's so much physical damage that an awful lot of places can't collect data because people don't have homes, and that's their priority right now. That's certainly the case in Lee County.
Dave, do you have a link to that dashboard?
I don't, but I think Christine Angelini does. And I think they're still working on it, but Christine and Miles are working on it, kind of using yours as a template of how to, provide so much information in such a easily understandable way.
Yeah, that's cool. I got to email Miles about that.
Yeah, Miles would be the best contact.
Any additional discussion on that item?
Yeah, hey Kelly, this is Chris Anastasio. I had my my hand up, and I know it's a little hand, so I just want to piggyback on some of the things that Dave was saying with respect to both the post Ian response. We've also been working with this larger group on Peace Myakka River sampling as well, and nothing directly in Tampa Bay with respect to post Ian water quality response. But one of the lessons learned, I think that we've taken away, we being the water management district has taken away from this, is the need to really start to think about water quality, both from bacteriological, nutrient, DO, this type of response. We need to formalize the procedure a little bit more, I think, and that was a lessons learned that I took away from that. So I'm multi-hatted at the district. One of the other jobs that I have, especially during hurricane season, is we have in our emergency operations center, I'm the weather operations lead. So I'm very busy tracking storms and briefing out our EOC. And so I've had a chance over the years of doing that job to really understand how the Division of Emergency Management works, how WebEOC works, and I see a need to really merge the sort of our environmental water quality groups that we have with some of the emergency management folks. So we actually have an after action report meeting tomorrow within our water management district EOC, and this is something I'm going to bring up to them, is that I think part of the reason why the district was able to participate in this response is because Charlotte County and Brandon Moody specifically worked with our EOC to submit their request as an unmet need through WebEOC to the Division of Emergency Management, who then routed that request back to us. So it became a more formalized process, which I don't think in the past we've done. So it's just something to think about as we move forward, especially for those of you who work for counties and local governments who have your own EOCs. It is a means by which to get that support formalized and possibly even reimbursed by FEMA. So just something to think about as we move forward. Hopefully we're done with this hurricane season, knock on wood, but moving forward and looking ahead to next year, I think it's something that we want to think about. I also had the opportunity in May of this year to attend the Governor's Hurricane Conference. I plan to do that again next year in advance of the 23 hurricane season. And I think this is a topic that I'd like to bring up to emergency managers throughout the state who probably aren't thinking along those lines. So I think it's a data gap that we can fill by going through that process. One last thing, and then I'll shut up. Ed did mention the seagrass transects. The district, we are on schedule next week to go out and hit 5 of the fixed seagrass transects between Port Manatee and Wolf Branch or Cockroach Bay. So we will be doing that work next week. And then just one quick update on our seagrass maps. We are very close to getting the numbers released. We're a couple of weeks behind schedule now because of Hurricane Ian and just everything that went into that. But I anticipate that we're going to have our draft final numbers by probably mid-November. So I'll be reaching out to all the estuary programs individually to talk about their respective estuaries. And then we're looking at maybe December as a time to schedule the seagrass working group to go over the results with the seagrass community at large. So Ed, Maya, I'll get with you guys on, possibly picking a date sometime here in the next couple months to do that. I think that's it from me. So thank you.
Hey, Maya, I had one little thing to add as well, and that is, we started off this proposed effort within 3 days. We went from concept to implementation within 3 days. So again, the shout out to the district for being so helpful, to Charlotte County. Also, we're paying for sampling outside of our watershed and all that sort of stuff. But we based it on the response of the Peace River in Charlotte Harbor to Hurricane Charley in 2004. And this is much worse. And we're seeing impacts across a broader area, and we're seeing rainfall amounts that have never been seen since I've lived in Florida. So what we're seeing, Chris and I were out there, we're 2 miles offshore in the Gulf of Mexico between New Pass and Venice Inlet. And we saw duckweed out in the Gulf of Mexico, duckweed and water hyacinth alive because these giant plumes of fresh water. So it looked like the Mississippi River Delta, like seeing freshwater marsh vegetation pushed 2 miles out in the Gulf of Mexico. And it wasn't dying. It was like it was brought there, readily enough with enough freshwater plume behind it. And so that is something that we've not seen before. I've never seen salinity stratification in the shallow waters of Little Sarasota Bay. We're seeing it now. So just the amount of fresh water associated with this rain event was just phenomenal for us.
Okay. Thank you. Chris, I'm really glad to hear that, that you're engaging in kind of the emergency management side of things, because I know, when Ada came through, we went out and just, started doing monitoring as soon as it was safe. And that wasn't a rain-driven event, it was just wind. So it was, more focused on any, public health type impacts, but this definitely does need to be, something in all of our emergency management plans, as to, not just from, the environmental perspective, but are we putting people in harm's way who are trying to do work out there and restore our communities. So it's a really important conversation. Okay, so I think our announcements were deleted by Maya because we're out of time. So I just want everybody to take a look at the proposed 2023 TAC meeting schedule. Please add those dates as blocks on your calendar so that you've already got them set aside and you don't miss any meetings. And with that, I don't have anything else, Maya.
I just want to make sure everybody knows that we welcomed Carrie to our staff, Carrie Flaherty Walia. She's our new restoration ecologist. Hopefully you'll all get to work with her. And then I also just want to put out there, if you can email me your preference for whether or not we continue to meet virtually or if we go back to in-person meetings. I'd appreciate your feedback on if that needs to change or if you all are still enjoying the virtual approach to the TAC meetings. And if you, it's listed there, but if you aren't aware, as a result of the 6 inches of rain that fell near Piney Point, they did resume discharges as part of the closure facility processes again. And so to my knowledge, they're still ongoing, and they'll notify us when those releases are done. This is the stormwater that has not come into contact with the mixed process seawater. So just so you all are aware of that, and the monitoring summary report that we did for the prior discharge in August is available on the TBEP website. If you have comments for me about Don's presentation about clay flocculation and HABs, or about Sid's letter for the city of Tampa related to their request to consider the direct discharge of their wastewater effluent as an ecological benefit for Tampa Bay, please get those to me by 10/28. That's not this Friday, but next. Appreciate y'all.
Yep. Okay, with that, our meeting is adjourned. Have a